Morning, everybody. My name is Richard Lawrence. I am a user support specialist at Texas A&M's High Performance Research Computing Group. And today I will be your instructor for this short course, Python for New Programmers using the ACES cluster. I just need to wait a few more minutes to make sure everyone has a chance to join our Zoom session, and then we will get started. Okay, so I see 61 people on Zoom. So that's a very high number of people on Zoom. I suppose it's a good time to get started. So we're here to learn Python. So today I'll be briefly telling you a little bit about Python, and then we will jump right into logging on to the ACES cluster, and we will use the Jupyter IDE to start practicing Python. And so we've broken down our Python concepts into 3 chunks. The first chunk is basically hello world. Then we have the second chunk, which is a broad overview of basic topics. And the third chunk is a more advanced topic, which is control statements. And of course, this is not all the topics there are in Python. So we're going to have more courses like these next month. There will be one where we continue and learn about data structures. So, overview of Python. This course is aimed at someone who may never have programmed before. If you're a new programmer, I have an opinion about what programming is, and so I want to share that with you. So here's what computers do, or I guess more accurately, what computers don't. Oh, my font got messed up. It was supposed to say what computers don't. So computers don't think, they only follow instructions. Computers don't understand what you want, they do what you say literally. That's actually not a concept that is unique to computers. So before computers were invented, we had fiction about things that are overly literal. So here's Disney's Fantasia from 1940. Mickey Mouse doesn't want to do his chores, so he tells the broom to do his chores. But he does not do a very good job of explaining what his chores are, so the broom ends up making a bigger mess than when he started. You don't want that to happen to you, so we have programming languages. Programming languages are a way for you to explain what you want very clearly so the computer cannot misunderstand you. So Python is a programming language. Why do we like it? Mainly because it's for free. The best stuff in 2025 is open source. That's my opinion. Python is open source, so it's for free. Windows, Mac, and Linux all have it in their app stores for free. You can also find Python online for free. So Google Collaboratory, Replit are online ways to work with Python. Python has been updated a couple times, so there's an older Python 2, and Python 3 is much better. So definitely stay away from Python 2. If you happen to see it, immediately upgrade to 3. So today we'll be using Python 3.10. That doesn't particularly matter. All the versions of Python after 3 are very similar. So we have some learning resources. I have some links here. The first link is the link to the page where you registered for this course. And I have uploaded this slideshow to that page. So if you want to open it and read through it at a later time, you can do that. We have a knowledge base. A knowledge base is like a wiki, but we've stopped calling it wiki recently. So it's knowledge base now. And we have pages about all kinds of stuff, including Python. We have a YouTube channel where we upload short videos on how to do specific tasks and also longer videos of tutorials like this tutorial. So as someone asked in the chat, will there be a video of this? Yes, and it will be on our YouTube channel. So if you go there now, you can see probably some previous times we taught Python. This one will be a little different. So hopefully you and find it to be useful. And I also think that the Access CI community does a very good job of curating useful links. So if you haven't seen the CI links page, do check that out. There's tutorials there for other things, Python, different scientific softwares, and it's high quality. So who's ready to get started? Who's ready to log into ACES? In order to log into ACES, you need to have an access ID that you provided to us at the time that you registered for the course. Then we would have set up your account on ACES already by now, hopefully. If you didn't register this morning, you registered this morning, then your account may not be ready yet. But hopefully for the most of us, your account will be ready. So we need to find the ACES portal. The ACES portal is a URL, and you can type the URL or you can find the button that is the shortcut on our homepage. So our homepage is hprc.tamu.edu, and the portal menu has a drop down to each of our clusters. So you'll just find the one for the ACES portal, which is near the bottom. I don't think it's the actual bottom item because we have more clusters now than when the screenshot was captured, but it will definitely be in that menu. So if you don't want to type, you can do that instead. We'll also just drop this link in the Zoom chat. So that's the link to our portal. So the portal is an instance of Open OnDemand, and it is authenticated using your Access ID. So your goal is to get to the landing page for the cluster. In order to log in, you will redirect you to Access CI logon. So it will redirect you to Access CI logon. So you have to choose how you authenticate to Access. If you're using a regular password, then that would be the exceed option for logging in. But if your account is connected to your institution, then instead you will use the drop down to choose your institution, and it will redirect you to your institution's login. So for example, when I do this, I click Texas A&M and it redirects me to the A&M login. If you're not at A&M, you would select your own institution, or if you don't have an institution linked to your Access account, then you would select Access CI Exceed and you will just do the regular password style. So how is this going for everybody? Can you throw a thumbs up in Zoom if you successfully found the ACES portal and authenticated using your Access credentials? Oh, I thank you for showing the thumbs up. I forgot I was supposed to use a different one than thumbs up. Okay, so if you're having difficulties, please do speak up in the Zoom chat. There are lots of HPRC staff in the Zoom today who can help you with your difficulties. It's important to get as many people as possible successfully authenticated before we move on.
Hi, Richard. So I am logged into Access Demand Portal, and from there, do I have to get into Jupyter Notebook for Python training?
That is what we'll be doing.
Okay,
That's the next slide I will be showing.
okay,
But I am waiting to make sure that everyone has a chance to log in.
sure, thank you.
So, Richard, I created an Access ID like a couple of days ago, I think on Tuesday. My institution shows when I select log on, it says that I don't have an Access ID.
Um, okay. When you registered for this course, you would have provided your Access ID. Did you register for this course using our registration form?
Yes.
Okay, so we should have knowledge of what your Access ID is. I'm going to ask our staff to check the status of your Access ID.
All right. Thank you.
I do think we have his. Give us a minute to look.
Or the web portal, because we can serve it directly in your browser. So please go to the interactive apps menu and find the Jupyter Notebook for Python training, which will have the shortcuts that make it much quicker and easier for you to get started. Not as many buttons, I automated some things. So once you reach the notebook for Python training form, there's an email field that you can ignore, and there's a launch button. So do click the launch button, and then you will get a page with your interactive sessions that are currently running, and it will say queued, it will say starting, and eventually it will say running. And after it says running, you will have a button connected to Jupyter, so you'll please click on that, and it will open in a new tab the Jupyter IDE. So the Jupyter IDE opens with a file navigator, and hopefully you can see some files. And the three main files numbered 1, 2, 3 are for the three parts of this course. So first we're going to open the one numbered 1, Jupyter and Hello, which you open in the navigator by double clicking, or I think you can do like right click run or something like that. I usually just do the double click. So that will open in another new tab. And that new tab will be the Jupyter Notebook editor for Python code. So that will start with that will have a card at the top saying Python for new programmers. So I'm going to also do this procedure. And I don't need the slides on my screen anymore. So I'll just focus on my own browser for now. So in my browser, I'm going to do interactive apps. I can't remember if I already have a running session. I guess I should check that. No, I don't have a running session. So mine are labeled completed. So I need a new one. So I'm going to Jupyter Notebook for Python training, launch, queued, running, connected to Jupyter. I'll make my font a bit bigger. I found the notebook number 1 open. So you open the notebook, it becomes a new tab. Python for new programmers. Presented by High Performance Research Computing, Texas A&M University. That's us. Can you give a, let's see, what are the options called again? There's a green check mark. Can you please use the green check mark reaction in Zoom if you have opened the Jupyter Notebook with the one Jupyter and hello file that says Introduction to Jupyter Notebook. So the reason I've asked you to use the green check mark is that one will float around, that one will not expire immediately. So I can see over time how many green check marks there are. Okay, so we have a red X. I would like to investigate a red X. William Many. Can I help you with your red X? Or is it working for you now?
So I don't have access to the ACES cluster and I wasn't able to sign in properly, but I do have Google Colabs open with a blank, untitled Jupyter Notebook. Is that all
Okay,
right?
if you have Colab, we might be able to get you a copy of the files.
Oh, that'd be great.
So for this file, blank Colab is fine. For the other ones, you probably want a copy of our file. I will ask my colleagues to work on that while I resume teaching.
Thank you.
What is this collab thing that he's mentioning? I didn't join that.
Google Colab is a different IDE that's very similar to Jupyter. That's for free online. It's not the one I'm using, but if you couldn't log into ACES, it's a decent backup option. So I'm going to, for this notebook, if you just have any IDE, that's probably good enough. And we're going to try to get you a copy of the second notebook by the time you need it. So I'm going to proceed. Introduction to Jupyter Notebook. So Jupyter Notebook is an editor for a file type named IPython Notebook, IPYNB. IPython notebooks are files that are broken down into cells. So Jupyter can edit that file type. Colab can also edit that file type. The main thing about it is that your work is broken down into little pieces called cells, so you can just work on one piece at a time. So let's learn about managing the notebook. So you have a file, and of course that means you need to save your file. Now it should be auto-saving regularly, but you can never be too careful, so go ahead and find the save button. Make sure that works for you. It doesn't actually show me that it has saved. In some editors, it'll go like last saved when, but in this one, it's not showing that to me. I assume I need a plugin for that. So let's talk about the runtime. Jupyter and Colab both have a concept called a runtime, which is the Python interpreter is a process that is running on a node somewhere. So if it's ACES, it's running on a compute node. In Colab, it'll be running on a node in the cloud. That process is called the kernel. It's the thing that interprets your code. And the kernel can get into a bad state. So an example of a bad state is if you accidentally deleted some really important variables that Python needs to survive, then it won't be able to do anything useful. So in order to reset the kernel, we have a menu kernel restart runtime. So if you click that, it's basically the same as deleting your variables and getting fresh new variables. That is the point. That's for when your variables are messed up and you need to start over. And other IDEs have similar menus. It may be named runtime or something else. So that restarts the Python process that interprets your code in case some variables have gotten into a bad state. We'll talk about what variables are later. So cells, Jupyter Notebook is organized into cells. And here's an image of a cell from biology for your entertainment. So you need to click on a cell to highlight its boundaries. When I click on a cell, it highlights the boundaries of the cell, so you can tell where one cell ends and the next begins. There are two types of cells. We have code cells and text cells. So this one is a text cell. And below it, we have a cell that's a different color, and it has brackets on the left. That is a code cell. So code cells are where we put Python code for the interpreter, and text cells is where we put pretty human readable text for you, the student, to read. So code cells are meant to be executed, and we use the word run as a synonym of execute. That means the Python interpreter reads the code and follows the instructions. So to execute a code cell, you have some options. So we have a run button in the toolbar. You also have menu options for running cells. And you have hotkeys like Control Enter. So your example code cell is this one below where it says example code cell. So you have to click on the code cell so that it is the selected cell, and then use one of the run methods to execute this code. So I'm going to use the run button in my toolbar. When I use the run button in my toolbar, a couple things happen. So first, the bracket, if you look closely, the bracket changed from empty to the number 1. Next, underneath the code cell, some more text appeared. This is called the output of the code cell. And finally, Jupyter advanced my selection to the next cell. So there's more than one way to run. Some of them advance your selection, others leave your selection in the same place. So you just have to get comfortable with which you prefer. It's a style.
Sorry, Richard, we can see your screen.
You can see my screen.
No, we can see your face.
I can see the screen.
I can
Zoom,
see a screen.
Zoom, it looks like I'm sharing screen. Do you maybe have swap presenter view and screen sharing view as an option or something like that?
I'll check. Thank you. Oh, yeah, I think so. I have this. Okay, thank you.
Okay. I guess that's a good time to stop for a question. If anyone has a question about executing this code cell. So the three pieces you are meant to pay attention to is the bracket changed to the number 1. And the number 1 is tracking the order in which you executed code cells. So this was the first one I executed. The output, a lot of code generates output because you have to, that's essentially the result of executing a code cell is its output. Usually we include output in code so that the user will know it has done something. Not all code does that. Did anyone have a question? Oh, I forgot to actually check if someone had a question. I didn't see a question yet. Okay, so I'm going to scroll some further. So your exercise, the first exercise for any new programmer, this is a tradition that goes back older than me. The traditional first program in any programming course is the Hello World program, which has the output. Hello World. So if you want to participate in the ancient tradition of Hello World, then you have this exercise. So the steps are: scroll down to the blank code cell, click on it so that your cursor is in the code cell, and then type the text, print hello world with the parentheses and the quotes. Try to make it match exactly what's in the instructions, and then execute the cell, and then replace the word world with your own name if you want the code to greet you, and execute the cell again. So those are the two common variants of hello world and hello your name. And when the text appears in the output of the cell, you have succeeded. And I would love to know if this is your first program in Python or in any language, and we will give you a round of applause because we're very excited for you to join the wonderful world of programming. So please give the Zoom reaction if this is your first program, and we're very excited to welcome you to the wonderful world of programming. Congratulations to our new programmers. It's nice to have you here. So while I have your attention, I'll just make a couple of more comments about this code. So the text that is in the quotes is called a string. We'll talk more about strings later. The text that is the word print and the parentheses that are attached to it is called a function, and we'll talk more about functions later. So we've just learned how to make output. Now we have to learn how to get rid of it. Sometimes programs can produce a lot of output, and that will clutter up your screen. So how do we get rid of it? Well, I have a hello world output. You can get rid of one at a time using the right-click clear cell output, which is also in the edit menu, I think. Yep. So you can get rid of it one at a time, but that may get tedious. So then we also have the edit clear all the cell outputs, which gets rid of all of them and makes your notebook tidy again. And if you are restarting your kernel, you probably want to also clear your outputs so you can tell which outputs are from the old kernel and which ones are from the new kernel. So we have the restart kernel and clear the outputs as a shortcut for doing those two things.
What is the kernel?
The kernel is a process that is running on the same node that is the Python interpreter that will interpret your code. So the Jupyter Notebook has multiple pieces. You've got the web server that is serving this content to you in your browser, but you also have the Python interpreter that executes code. And those are two separate processes. So if one dies, it can be restarted without interrupting the other process. And that's really handy because programs sometimes crash. And if your program crashes, you don't want your user interface to also crash. You want to be able to restart your program and not have that interrupt your user interface. So that's why the kernel is separate from the web server in the Jupyter IDE style of programming. The kernel is, again, it's the name of the Python interpreter process that is separate from the web server that's serving you this user interface. So we have some optional topics here, fun facts about cells. You can do the exercise to create some cells, to edit a code cell, edit a text cell. You can take a few minutes to do these if you want. This is optional, so I'm not going to read it out loud. I'll just wait a moment in case people want to do these exercises. So there's the menu for switching a cell between code and markdown and raw. I don't know what raw is for, but I use code and I use markdown.
What is
Excuse me.
Markdown?
Oh,
Markdown is it's not a programming language. It is a typesetting language. So that's what Wikipedia uses to control the text formatting in Wikipedia. So the syntax for make it big is you put a hash mark at the beginning of the line, and then when you execute a markdown cell, then the markdown interpreter transforms that into pretty human readable text, which is it's not exactly a programming language because it doesn't do math. It just controls the appearance of text. That's all it does.
Okay, thank you.
So that is a typesetting language.
yeah, thank you. Sorry, I used the kernel restart and clear out all cells, but I still have the text in the code cells. Is that intentional?
The text in the code cells. So for example, this text here, this is not deleted when you restart your kernel. And that's because if you're in the middle of writing a program and it's not working, you don't want to delete your whole program. You just want to try again. So you have to manually delete the code that you think is the problem. It will not delete all of your code for you.
All right, thank you.
That is a good question. Does everybody feel satisfied with the welcome to Jupyter Notebook and you feel ready to move on to the next topic?
I have
Actually, you know what would be a good time is it might be a good time for a break. We like to take breaks.
I have a question. Once you have the section editing cell and you have the red color says exercise create a cell. So I clicked there and I put enter because I thought it will create a new cell. It became like this. How can I fix that?
Okay, so while you're editing a markdown cell, you see the markdown language. And when you are done editing a markdown cell, you transform that back into pretty text. You simply execute the cell. So you could use the run button, and then the markdown interpreter will transform that back into pretty text.
Thank you. Sorry for my silly question.
Not a silly question. I accidentally edit text cells all the time, and I go, oh, I didn't mean to do that. And then I have to remember how to undo what I've just done. So a break, I think, is in order, because we have been in the Zoom session for about an hour, and I don't want to start a new topic before we've had a chance to take a. You have a question about break time?
No, sorry, about the philosophy of Python a little bit, since it's slightly non-technical. That's why I thought this might be a good time to get your view on it.
Yeah, that's a good time to ask.
Yeah, thank you. So as I know, like C++, Fortran, all these things were good for programming, and Bash scripting was good for like scripting and management purposes of the files, right? So Python has kind of both abilities. As the more I read, I understand. So if I, I feel like I learn a bit and then forget a little bit. So to keep up with it, should I focus with Python the scripting tool, or like which would be better to get on board and keep up with it? Like, should I convert all my file management system into Python scripts from Bash, and that's what I should focus on? Or should I try to write codes and like the codes that I have in maybe C to using Python, which would be a better investment of time in terms of long-term learning?
I don't think any one language is the right choice to do all tasks. So if you ask me like what I actually use after many years of experience with C, Python, and Bash, the answer is I use all of them. So I did not replace my file management from Bash to something else. I still use Bash for file management. And I did not replace the things that C is good at with Python. And in fact, if you dig really deep, a lot of the applications that look like Python are calling C libraries under the hood because there are things that C does better. So Python, I kind of think as it has two main use cases. The one is it's good for development. Like when you're trying something new for the first time, Python is a good choice because its syntax is simple enough that the syntax is not going to hold you back from doing your development. And the editor is very forgiving. It will give you hints about what you've done wrong and let you fix it while you're working on it. So when you're doing development, Python is a good choice because you can rapidly move through different ideas you're having. And then the other good use case for Python is as a kind of a glue between different pieces of a complex system. So an example of a complex system might be something like a container runtime. That has to be able to handle files and processes, and it has to be fast. And so a container runtime might have a kernel that's written in C, but it also needs to work with files. And so you need a kind of a glue between those two, and Python can be that glue because while it's not fast and it's not native, it's good enough at doing both of those things that it can connect them together. So those are my favorite use cases for Python, since you did ask. Does that help you understand?
Yes, yeah, it does. Thank you very much.
Aza has asked an interesting question in the Zoom chat. I would like to respond to it verbally. Aza has been doing 100 Days of Python. Congratulations, Aza. That's a difficult challenge. And Aza would like to know if Python is like Photoshop. In Photoshop, there's multiple ways to get the resolution that you want. So I don't use Photoshop. If you're asking if there's more than one way to do a thing, that is kind of a philosophical question. Literally, the answer is yes, there's always more than one way to do a thing. But if you're asking the philosophical question, Python is a language with opinions. The philosophy of Python is there is a best way to do a given task, and it should be obvious what that is. So the Python language is kind of structured to steer you towards what it believes is the obvious, correct way to do a task. It's still possible to do tasks in different ways, but that is not the philosophy of Python. So we might see some examples later, and I'll try to, if I remember, I'll try to call back to your question. There is more than one way to do something, but there is what Python believes to be the best way. And if you don't prefer the same way that Python does, you might find it to be frustrating, and you might eventually choose a different language for that task, which is fine. Python is not the best at everything. So, for example, later today, we're going to learn about styling your code with white space and indentation. In many languages, white space and indentation are purely used for style, for readability, but in Python, they are also syntactic, which means the style is kind of baked into the language. You're not allowed to style your code the way you want. You have to follow Python's guidelines. And so if you don't like the way Python styles your code, you're kind of out of luck. You're going to have to pick a different language. But even if you really struggle, you can like argue with Python and convince it to style your code the way you want. It's just a lot of extra work because you're going against the philosophy of Python if you do that. You're going to make your code kind of ugly and weird in order to do it the other way, the way that was not intended. But it is still technically possible, even in Python, to style your code the way you want. It's just extra work and not worth it. You should use a language that matches your style rather than trying to make the language match your style.
That's really helpful. Thank you.
I also need to participate in this break, so I'll be going offline for a couple minutes.
I have a question before you leave.
Okay.
So in my department, or at least some people, I saw they use this Visual Code Studio or something like that for Python.
VS Code, is that the one maybe?
Yeah, that one. So
VS Code is very popular for Windows users.
oh, I saw them even using in the Mac.
Yep, you can even use it in Mac.
So why you will use that instead of this Jupyter or the other way around? Or...
So Jupyter and VS Code organize their files differently. So Jupyter uses the IPython notebook file type where code is organized into cells. And VS Code is uses the plain text file type where the code is organized into files. So whether you want to organize your code into cells or files, that's a style for the given project you're working on. And some projects will naturally fall into one or the other. So you're going to use the IDE that matches how your code is being organized. I believe that VS Code can also edit IPython notebooks, but that's not what it was designed for. So I assume most people who are using VS Code aren't using it that way.
I would add to that, my experience with both is that Jupyter is perhaps more useful if you're trying to do interactive discovery versus VS Code if you're trying to write code, as in you want to build a program to do a thing. It's probably easier to do that in VS Code, but Jupyter is really great at letting you rapidly iterate on testing out this, trying that, with the immediate feedback that it provides. I guess the point is they both have their use cases.
I use VS Code from time to time. I don't have anything bad to say about it.
I believe VS Code does do the like interactive notebook stuff like Jupyter does as well. The main reason I would choose Jupyter Notebooks is that it doesn't have a million other things it's also trying to do at the same time. Like VS Code just gets to be kind of distracting, whereas Jupyter Notebook is dedicated to these notebooks.
VS Code is the everything code environment.
Yeah.
And what we're using right now is a very slim code environment that's just for the purpose we need right now. As you grow as a developer, you'll need more features and you'll evolve past Jupyter and you'll probably use something like VS Code that has more features. But when you're just learning, those features are a distraction. So we've chosen a simpler editor for the just learning phase.
And is there a way to connect to MATLAB?
From
I
Jupyter?
I don't recall if Jupyter can natively run MATLAB code. I'm sorry.
And what about this VS Code?
I believe VS Code can natively run MATLAB code. It can program in almost anything because it's highly extensible. Are you trying to avoid the MATLAB graphical interface for some reason. MATLAB has its own graphical interface.
Yeah, it has its own language. Oh, I just think could be more convenient because it has more libraries. This Python, at least what I heard.
So
I want to run Simulink.
MATLAB and Python both have many libraries. I think in the past, MATLAB had more libraries. I don't think that's true anymore. I think that the Python community is larger and producing libraries at a faster rate. So going forward, having enough libraries is never going to be a reason not to choose Python. And I really do need to take, it's too late. It's my break.
I apologize.
Womp womp.
Richard, take a break. We'll entertain them for like 5 minutes.
Okay. Howdy, students. Welcome back from your break. It is now time to resume learning. We're going to get into the second phase of learning Python, elements of code. We're going to learn a wide variety of different elements of coding. Starting from the bottom, data, variables, operations, simple things that are foundational to any programming language and are represented in Python. So please, if you have the other notebook running, you can shut it down if you want to. I'll go ahead and shut mine down to show you how. It doesn't really matter. As long as you're only working on one at a time, then you'll have enough resources. But after you're done with that kernel, you close it down to make sure you're saving on those resources. So you want to open up your Elements of Code notebook, which will be a new tab. Python for new programmers, Elements of Code. Learn how Python code is interpreted and displayed in Jupyter Notebook. Learn about data types, operators, variables in Python. So please give a green check mark in Zoom if you have your file number 2, Elements of Code, open in a tab, ready to learn. Peter says, how did you access the new file? So my browser has tabs. So you can see my first tab is the ACES portal, where I've got my currently running Jupyter Notebook session. I made my font bigger, so it's occupying the entire column. If your font is small, it's probably not occupying the entire column. So when you clicked Connect to Jupyter, it would have opened another tab, and that tab is the Jupyter File Navigator. So under the File Navigator, you should be able to see multiple files, including one named 2 Elements of Code. So I just double click on a file to open it, and again, that opens in a new tab. So now I have 3 tabs. William is asking if we can upload this one to a Google Colab and share. Yes, my intention is that we will do that. I'm hoping one of my colleagues has already prepared that.
We're working on the uploads, yeah.
So wonder if I can do this myself. So if I go File Download, and then go to Colab, and then go File, Upload Notebook. Yeah, I can open that in Colab. And then I could go Share. Anyone with the link, copy the link. drop it in the Zoom chat. So that should be a link to this file, but in Google Colaboratory. So you need to go make a copy for yourself, because if you try to edit the file that I own, it won't work. But you should be able to go open, make a copy for yourself, and then that copy you'll be able to edit if you're choosing to use Colab to do these exercises. So I'm going to now start reading. We have elements of code. So the first element of code is comments. Comments are not code. That's because before you code, we use human language, and so we need to be able to represent that. So code that is comments are how you put human language among your code, and they start with a hash symbol. Everything to the right of a hash symbol, the Python interpreter will ignore. So here we have hash, this is a comment, and if I execute the cell, nothing happens. It is successful in the sense that you can see on the left, the bracket changed from empty to number 1. So that means executing the cell was successfully completed. It just had no effect because Python interpreter skipped reading this and there was nothing else to do. So why do we have comments? It is a good habit to insert comments throughout your code. They are a helpful reminder to your future self who has forgotten what the code is supposed to do. So if you were writing code and you come back months later and read it, you won't remember what it means. It's hard to keep all of that in your brain for months. So instead of hoping you remember months from now, just give yourself a hint and write a comment. And that way, when you or someone else reads the code, it will be much easier to figure out what it is doing. So you have an optional exercise with comments. If you want to take a moment, you do the hello world, print hello world, but then we add some comments. So you can see here that the hello world program works correctly because the comment did not affect the output. The word comment on the right of the hash did not appear in the output. So the next topic I want to talk about is data. The reason we have types of data is because there are different things you can do with data depending on what kind of data it is. So we have concepts like text and numbers, and we have a concept of arithmetic. Arithmetic is something we do with numbers, but we cannot do arithmetic with text. So if you want to have arithmetic in your Python program, then Python needs to know what type each piece of data is so that it can determine if you're going to be able to do arithmetic with it or not, for example. So here's an exercise with data types. So in these code cells, we have, they're very similar, 1 plus 2 and also 1 plus 2, but with quotes. They both kind of look like arithmetic. Are they both arithmetic? What do they do? So in any given programming language, the language's developers have to decide what this means. And so in Python, we have decided what it means. So the only way to know is to find out by running the code. So I'm going to execute the code. So if I run the cell that's 1 plus 2, the output is the number 3. Is that very surprising? 1 plus 2 makes 3. Python should agree, right? And then we have 1 plus 2, and the output is 12. 1 plus 2 is 12. Well, that's not arithmetic. What is that? Anybody know the name of what that is?
Is it a string?
That is correct. As we previously stated, when we put it in quotes, it is a string. Does anybody know the name of what happens when you put strings together. Anybody know the word for that?
I think it's
Concatenation.
concatenation.
Concatenation is correct. So this is called operator overloading, which means that the same symbol plus has different effect depending on what kind of data it's being used with. And in order for operator overloading to work correctly, we have to practice understanding data types. So that's our motivation going forward. So let's learn about these data types in a little bit more detail. Text data in Python is called strings, and that's abbreviated str in code. Strings are easy to recognize because they're wrapped in quotes, and your IDE will color code them, in this case, dark red. So we know that the Hello World program contains a string. Let's do some exercises. So below exercise creating strings, type some characters into the cell, mix and match different types of characters, mix and match different types of quotes, and see if the text turns dark red or if it gets the red underline that says this looks like a problem. So essentially the exercise is checking for typos. So I know that if I type double quote, hello world, double quote, that's a valid string because we previously saw that one. So if what if I change it up? What if I add some punctuation marks in the middle? That a valid string? It's still red, so it's a valid string. What if I change the quotes? What if it's single quotes instead? Well, it's still red. If I try to run the cell, it says unterminated string literal. So what that's telling me is I begin a string with a single quote, but I never ended the string with a single quote. So the string doesn't end. The double quote here cannot be the end of the string because the string didn't begin with a double quote. So the string needs to begin and end with the same type of quote. Is it clear to everyone what I'm trying to say?
So it's also a string when it's one of this upper line, upper comma. I don't know the name.
Yeah, I don't know that. I think it's called maybe apostrophe.
Okay, yeah, that one. If you do one apostrophe or double apostrophe, it doesn't matter.
So that one apostrophe with the letter A is a string, and the two apostrophes character with the letter A is also a string, and three single apostrophes with the A is also a string. What about two single apostrophes with the A? If you look closely, you can see the A is not red, it is black, which means it is not recognized as part of the string. So what this is a string here, a string with the letter A that opens and closes, the letter A that's not part of a string, and then another string with the letter A that opens and closes. So if we take these A's out, now that's an empty string, the letter A, and another empty string. So if you want to use multiple single quotes, the only correct number is 3 of them.
Sir, I think the question is more so around why do you have 3 different kind of quotes if
That
it's
is a
only
good
one of the
question.
first string?
I would
Yeah.
like to answer that. So let's suppose you're writing a string like I haven't got any plans. Can you recognize the problem with my string?
Oh, you have apostrophe in the middle of the sentence, which gives an error message.
That is correct. So I wanted to use the apostrophe as part of the string's message. So if I'm using the single apostrophe as the opening and closing, but also in the middle, now it's ambiguous. Where does the string end? Is this the string? So in order to include quotation symbols within the text, you have to have a different quotation symbol as the beginning and end. If I change it so that the string is terminated by double quotes, now it's fine. But that won't work every day. Suppose it's, he said no. So these double quotes are meant to be part of the string, but they're not. So now we have to change it to single quotes. But what if you need both? He said, I haven't got any plans. Now we're in a real pickle, eh? Well, we still have the triple quotes option, because we know the triple quotes cares how many there are. So the triple quotes says only 3 can open, only 3 can close. So now you can put both types of quotes within the string, as long as you don't put the triple quote within the string. I don't know why the triple quote would ever be in the string. But essentially the reason for having different kinds of quotes is in case the quotes need to be in the string itself, you've got some options. Did that make sense?
Yeah, that makes perfect sense. Thank you.
Okay, so I think that's enough about quotes for now. Let's talk about numbers. So Python distinguishes between 2 classes of numbers. We have the integers, which are like the counting numbers and also the negative counting numbers. And then we have everything else, which falls under the category of float. Float is short for floating decimal point, which is the decimal point representation of rational numbers. You can also express rational numbers with fractions, but Python will internally convert them to the decimal point. And then you have some weird things like the concept of not a number, which is also a float. So some random catch-all miscellaneous cases fall into the float category. And there is a reason why we have 2 different kinds of number data that we will probably learn more about next month when we do data structures. For now, we just have to be aware of which one is which. So let's practice creating some numbers. So if we type some digits into the cell, they turn green. Green is letting us know that it's recognized as a number. So we need to try some different combinations. If we put a decimal point in there and look very closely, you can see that the decimal point is also green. It is part of the number. If you insert a minus sign, oh, it turned purple. I was expecting it to turn green. So in some IDEs, the minus sign is part of the number and will turn green. I guess it's not doing that for me today. So if the minus sign is there, it's purple instead of green. Let's talk about some things that aren't numbers. If we try to put a second decimal point in there, that's not a valid decimal number, so the decimal points turn black. You can have a decimal point at the beginning of the number, and that's fine. Python will understand that it should add the implied leading 0. You can have a decimal point at the end of a number. That's fine. Python will understand it needs to add the implied trailing 0. but this decimal point didn't turn green because at that point in the code, it wasn't determined yet if this was 5 point, and then maybe I was going to go on to write some different code. But since I didn't, it just interpreted as, oh, this is an unfinished float literal. If you add another character, the decimal point turns green because now it can't possibly be anything else other than a float. We'll get to another use case for the decimal point later today to explain why the dot doesn't turn green until you add another digit. Did anyone have a question about entering these numbers? I would like to challenge you. Have you ever used a calculator, like a literal handheld calculator with scientific notation? There is an old notation for scientific notation using the letter E. Have you heard of this before? So a lot of old handheld calculators use the letter E to represent scientific notation. And Python also respects that. So watch this. 5E6. And you can see that the letter E turns green, even though it's not a digit. It's still part of the number. Isn't that fantastic? So if I execute the cell, Python internally converted that to the regular decimal representation for 5 million. If you had put a different number, if you had put a different character there, like maybe an F, there's no such number notation 5F6. That's not a valid number, not even on a calculator. So it didn't turn green. That's not understood to be a number.
I have a question. Can you add H for hexadecimal? Will it understand?
There is a hexadecimal form in Python, but it's not the letter H. I think it's something like 0x. Let's check. Aha! I was right. So, if you're familiar with hexadecimal, hexadecimal is a different way to represent numbers that Python also uses, and hexadecimal literals start with 0x, and then they can contain the characters A through F among their digits. So the X is part of the number because it's indicating what representation the number is, and the F is part of the number because it is considered to be a digit in hexadecimal. So both the X and the F turned green. And then internally, Python converted that to an, what is this? That is an integer, 246 the integer. Is there such a thing as hexadecimal floats? Apparently there is not. Shows what I know. I hardly ever use hexadecimals. But thank you for the question.
You're welcome. I have a question also. Why it doesn't recognize the points and the minus if they are numbers as well?
Some IDEs do. So in Google Colab, the minus sign turns green because it's part of the number. I think that's just a personal convention because the minus sign could be it's part of the number, or it could be the operation subtract. And that's kind of ambiguous. So at this point, I can't tell you which one is better.
Okay, because in MATLAB in the past I experienced that issue that it depends which minus do you use. It's different. So sometimes the code looks fine, but you are using some minus and it doesn't work. But if you change this minus to another minus, it works.
Python respects both the, what's it called? There's a word for operators with one operand, and there's a word for operators with two operands. And there is a minus operator with one operand, and there is a minus operator with two operands, and they use the same symbol. So minus 1 is valid. Also, 2 minus 1 is valid. Those are technically a different math concept, but they use the same symbols. And in Python. So if there is a long dash symbol, but Python doesn't use it for math. That would only be used in strings. Thank you for your question. Let's move on to logical data. The word for logical data in Python is Boolean, or bool for short. Fun fact, bool, I believe, was the name of a mathematician who described using the concepts of true and false to do math. Logic is kind of a math topic. So Boolean is the name of those values. So Booleans will be color-coded depending on your editor. In Jupyter, they go green. In Colab, they actually go blue. That's just an editor choice. Oh yes, Bool with an E. Apologies for Mr. Bool. I forgot the E in his name. So in Python, bool without the E is short for the value is true or false. So if the text turns green, it's a valid Boolean. So if I type false, but it didn't turn green, that's my first hint that I made a mistake. Can anybody tell me what mistake I made?
F is a small letter.
That is correct. So Python is a case-sensitive language. The small letters and the big letters are different. In this case, it distinguishes between the value false and the word false that isn't a value. That might mean something else, but at this time, we don't know what it might mean. And in general, Python is case sensitive, but there are some languages that are more flexible for case. So you might see some code like in a language like R, where the capitalization is, you got some options. In Python, you have no options. You have to do it exactly a certain way. So let's do inspecting data. After you've created some data, you would like to know what Python thinks the type is. So we have the type function, which we use for inspecting data. So just put any code element in the type function's parentheses and run the cell, and we'll find out what it is. So we've previously seen hello world, which we know to be a string. So let's execute type hello world and see what Python has to say. So Python says hello world is a string. str is short for string. Let's put something else in there. How about a number, the number 5? And Python says that's an int. Int is short for integer, one of the two types of number data. Anybody want to try something else? What other elements of code do we know so far? We could put a Boolean in there like false, and it says the type is bool. We could put a floating point number in there like 0.1, and it says the type is float. Here's a tricky one. Let's put something in there that's not data. We've seen the print function before. If you do type print, the result is built-in function or method. And type is type, which is really funny. Okay, if type is type, what's the type of type? Also type. It goes forever. I don't know why it is that way. I just find it very funny. Did anyone have a different experiment you tried that you'd like to share with us?
maybe pi. Like I was trying to see if there's a special number like pi, so that
Okay, so
doesn't
if I
work.
type the letters PI, it says name
But
PI is not defined. So Python doesn't have a built-in number constant for pi, but Python does have a number constant for pi. It's just not built in. It is provided by one of those libraries that we're going to talk about later. So we'll come back to this later, I promise. How about some operators? So we previously saw some arithmetic operators when we were looking at numbers. Let's go ahead and look at the rest of those now. So we have these arithmetic operators that work the same as they do in your algebra course from primary school. In the Python, we use the symbol asterisk for multiply. Not the letter X, for example. And we use the symbol slash for divide, not the other possible symbol for divide, the one that kind of looks like a percent symbol. So I have a graphic here with some symbols you may have seen in your math class. Python doesn't use the X and it doesn't use this line with dots. They are real characters. They just have to be in strings. They can't be for doing arithmetic. And then we have the parentheses, which are very important. The parentheses determine the order of operations. So if you have multiple operations and you're not sure about the order, or you want to guarantee the order works the way you want, then you use parentheses to make sure that happens. Spaces are not required, but they are helpful for readability. So spaces between operations and numbers are they're just for style. So let's do some exercise. It suggests doing this large multiplication. Let's try the large multiplication. Okay, that's a huge number. There's no way I could do that by hand. Do you want to, let's try some experiments. Let's try 10 divided by 2. So that's 5.0. That's interesting because 10 is an integer and 2 is an integer. Let me prove that to you. So the type of 10 is an integer, and the type of 2 is an integer, but the type of 10 divided by 2 is a float. Why did that happen? Does anybody have a hypothesis about why that happened?
Is float just an automatic output if there's a mathematical function?
Good question. Let's try a different mathematical function. So 10 plus 2, that's 12. I don't see a decimal point. What type is it? It's an integer. So some math operations result in integers and other math operations result in floats. What if we mix and match? We can do math operations with floats, right? So 10.0 plus 2.0 is a float. So this is another example of operator overloading. The result of the operator depends on what types it was used with. But not in the division case, because the division case, we only see integers and yet the result is float. So division is one of those special operations where the result, the type of the result is not determined by the type of the operands, but instead it will always be float. But what if you want to do a division and have the result be integer? Well, good news. There is an operator for that. It's double slash, which is the integer division operator. So 10 double slash 2 is 5, the integer. So that's how you do that. Now, There is a use case for this that will come up another time. For now, you just need to know that types are the type of the result will match the type of the operands when it can, except for the case of division, because with division, you have two operators, one for making floats and one for making integers. Let's see, was there another one we wanted to do? Parentheses. Yes, we need to do parentheses. So let's do, one of those math problems that makes the people on the internet mad. 1 + 1 × 2. You'll see on Facebook going around, there'll be a math problem that essentially boils down to this. And there will be some distractions as well to make it look harder. But at the end of the day, the point is, can you remember order of operations? And about half of people on Facebook forget order of operations, and they'll say that the answer should be 4, and then we laugh at them. So the answer is 3 because Python respects order of operations. Multiply comes before addition.
I have a question. Does Python also handles matrices?
Python does have matrices, but they are not built in. Those are provided by one of those libraries. So that is a difference between Python and a language like R. So R is a language that most of the math concepts are built in. But in Python, the base language is more trim. In order to use math operations that are more complex, you have to bring in one of those libraries. But don't worry, it's very easy, and we'll get to it literally later today. Although I don't think we have an exercise about matrices today, but I can show you if you're very curious how to do that.
I was curious actually more parse matrices, because I know sometimes, for instance, in MATLAB, if you use normal division, it doesn't work. We used to use the / division, and then it works. I mean, it does another process behind.
Well, yes, that's correct, but it's not R's fault that division is complex. Division is inherently complex. That's true in any programming language, and indeed in math as well. So every programming language will have different ways of dealing with the complexity of division, and I'm not going to complain about it. Let's just say it like that. Okay, so if we wanted to make the order of operations different, you would add parentheses, and now we have 1 + 1 × 2 is 4. Were there any questions about the parentheses? They work the same as they do in your math class. So hopefully you are not surprised by this. I am ready to move on to the next kind of operators. So now that we've learned arithmetic, arithmetic operators transform numbers into numbers. But numbers are not the only kind of data. We also have Booleans. So we have conditional operators that transform numbers into Booleans by comparing them to see if they're related to each other or not. So there are different kinds of arithmetic relationships. We have inequalities and we have inequalities. And so the result of an equality or an inequality will be a Boolean. So that means we can combine different operators into a single line of code. So here we have 1 + 2 = 2 + 1. Careful with the equal sign. You need the double equals sign. We'll talk about that a little bit later. So for now, we're just trying to understand. So according to the table, double equals sign is the equality operator. So what we're doing is we're comparing the two numbers to see if they are equal. So on the left, we have 1 + 2, and on the right, we have 2 + 1. Can anyone predict what the output of this will be if we execute it?
True or false?
It will be true or false. Can you predict which one it will be?
True.
Okay, let's try it. True is correct. So how do we get from this sequence of operators to true? Actually, it's not as trivial as you might imagine because we need order of operations to get this result. We need to do the additions first. So if we were to break this down, we need to get 3 equals 3. So the first thing we need to do is evaluate the additions, but not evaluate the equality. And that means order of operations has to apply. And so we need to know that the conditional operators come after the arithmetic operators in the order of operations. What if we mess with the order of operations by adding some parentheses so that it can't work that way anymore? So now there's no way for the additions to be evaluated first because I've put some parentheses in there. So what's it going to do now? Apparently 3. Does this make sense? Not really, because this one is a perfectly well-defined operation. 2 is equal to 2, so the result is true. But now you're adding 1 plus true plus 1. And that doesn't really make sense because true is not an integer. So how are we adding it? We're adding it using the secret extra ability of operators to coerce values into different types. So while true is not a number, it can be coerced into a number. And in this case, the value of true corresponds to the value 1. And there will be some use cases for that. It makes your code a little bit simpler sometimes. But in this case, it's just giving us a kind of an unexpected outcome. There is a reason why true corresponds to 1 and false corresponds to 0. I guess we could prove that, right? So 1 plus false plus 1 is 2 while we're here. So false corresponds to 0. That's there for a historical reason, which is related to programming languages like C, which internally implemented Boolean logic using integer arithmetic. So then in languages like C, you had to understand the correspondence between the integers and the Booleans. And so for historical consistency, Python respects that, but I don't think it's like a requirement. You don't have to do that. So let's try a different conditional operator. 4 greater than 5. So that's just false. 4 greater than 5 minus 3 is true. Any questions about the conditional operators while we're here? I think our lunch break is scheduled for 12:30 Central Time. Is that correct? Does anybody care what time we break for lunch? If you have an opinion, I guess you should go ahead and share your opinion. I'm planning to continue teaching until the scheduled lunch break time.
I think it's officially 12:30, yes, but like if you find a good stopping point at 12:20, I won't be mad at you.
Okay. Well, we still have more things to learn. So I'm going to continue. Let's learn about concatenate operators. So we previously saw concatenate operator in action by accident. And the symbol for concatenate operator is the plus symbol. And yes, it's the same symbol as math addition. That's called operator overloading, when one symbol can mean different things depending on the data. So let's practice with concatenate operator by joining hello and world together. So let's have a string for hello, and then we'll concatenate and we'll have a string for world. Does this work? Do you predict this will give hello world? What do you think will happen? It gives hello world as one word with no spaces. That is not a valid word in English. So something I did wrong. Can anybody tell me what I did wrong? The concatenate operator doesn't create any characters that weren't in your strings. Since neither of my strings had a space, there won't be one in the output. Which means if I want to see a space, I have to add another concatenate operation. So if I do concatenate hello with space and then concatenate with world, now I get hello world with a space in between. Any questions about this exercise?
Sorry, why does the output still have the apostrophe? I mean, I was thinking it's just gonna be hello world.
So that is the difference between so the print function. Recall when we were doing Hello World, the program, we used the print function. The print function will omit the symbols that tell you what type of data it is and just focus on the data itself. But if you don't use the print function, this is a different way of inspecting data. A special case in Python Jupyter Notebook is if the last thing in a cell is data, then it will try to tell you something about it. So in the case of a string, it needs to tell you that it is a string, and it needs to tell you what the data is. And the simplest way to do both of those is to print the data and the quotes around the data. But the behavior will change depending on what kind of object it is. So if you put the word type, sorry. So if I put the word print here, it doesn't output the word print, it outputs this construction that's telling you what it is. So that's a special feature of Jupyter, that it will try to tell you something about the last thing in your cell if the last thing in your cell is data, or otherwise doesn't make a full statement. So that's why it's showing the quotes when we don't have the print function, because it's trying to tell you what it is. And there will be some use cases for that on a different day, where telling you about the item is better than just printing its value. So we have the more about operators optional section, and I need to decide if we're going to be doing that today. I think it's fine. I think it's fine to do the optional one. So let's do this one. More about operators optional. So here's the in operator. In is a conditional operator, but it's not an operator for arithmetic with numbers. It's an operator for strings. So recall, we have the conditional operators for numbers, the equalities and the inequalities. There are also conditional operators for strings, and one of them is the word in. So in is a conditional operator that compares two strings, and the result will be a Boolean, true or false. But unlike the equality operator, the in operator is looking for a partial match. So if the second string contains within it a substring which is equal to the first one, that is the partial match that is true. And the in operator has been overloaded. It also works on other things besides strings that we'll talk about on another day, but not today. So let's do the in exercise. Let's find out if the string cheese can be found in the string cheeseburger. So what do you think? Does cheeseburger contain within it the substring cheese? It does. I can see the letters, and so the result is true. Please try some different examples and see if you get the result you expect. And please try an experiment, because I think experiments are the best way to learn code. If I tell you the answer, you will immediately forget. But if you discover the answer by trying, you will not immediately forget. Would anyone like to share an experiment that you did with the in condition operator?
I tried one with a capital C for just one of the cheeses, and it does not, well, it returns a false rather than doesn't.
Aha, that is an interesting experiment. So what can we conclude for that experiment?
It's case sensitive.
That is correct. Python is case sensitive, and that applies within strings. And that can be a bit of a pain sometimes, because for example, if you're working with strings that you didn't type yourself, you might not 100% be confident what character cases are in there. So we're going to have to learn some ways to deal with that, and we will today. So that's a good experiment, because we're going to be coming back to that concept later.
One other thing was like in a list of words, like cheeseburger,
Python does
comma,
have lists, and the in
right?
operator does have a use case with lists, but we
Yeah, I
won't
thought
be
that
doing
because
lists today.
yeah. But my question is this: if somebody is trying to sort through a list, right, and it has their only objective is to find the whole word match, you know, like the actual word cheese instead of cheeseburger. So if that is not what they want in a list, and specifically want some other word, how do they eliminate those partial matches that this example is giving us?
So the in operator is overloaded. It has a different use depending on what type of data is being presented to it. So in the case where both of its operands are strings, the in operator does partial matches. But in the case where one of its operands is a list, then it doesn't do partial matches of strings. That's technically a different behavior, which is why I'm calling it operator overloading. If you're a bit confused, I'll just show you. So cheese in, and then I'll type a Python list, which is a concept for another day. Small cheeseburger. So the result of this in operation is false, because this in operation between a string and a list is not doing the partial match that the in operation on strings does.
Okay, thank you. And so in this case, I guess the answer is like you need to create a Python list like with those square brackets, because if we remove the square brackets, it will go back to doing partial matches and all that. Like, and
if you don't have the square brackets, this is still not a string because it's a tuple.
yeah, and remove the other extra things.
Well,
like
what you could do is you could use concatenate operator, because we know that concatenate operator produces strings. So if we do if cheese in one small cheeseburger, the answer will be true because the whole right thing is a string, and therefore the in operator does the partial match.
And even if we put just one pair of inverted commas, right? One pair of quotes, and like remove all the other quotes, but separate those extra words by commas. And like you can add other words like 1 comma cheeseburger, or 1
Do you
comma
want that
small
within
comma.
the quote or outside the quote?
Yes, yeah, within the quote. Yeah. And as if you are making a list. So this is also one string, right? So that's one.
Correct. It is one
Oh.
string because those commas are inside the quote. So they're not doing the data structure operation. They're just a character.
Oh, thank you.
But we will learn about the comma today, but we won't learn about the square brackets today. The square brackets is a topic for next time. I don't recall if we've already advertised it, but this is a series. There will be more, and the next one will cover the square brackets. We have a optional one for logic operators. I think you can do the logic operators on your own for a minute because they're not hard. You just need to type some Boolean values and logic operators into the cell and see what happens. So true and true. That yields true. So the logic operators, which are and or not full words, they combine Booleans to make more Booleans. So please take a minute and do a couple of those experiments. Okay, so I'm going to move on now. More arithmetic operators. I actually showed you the integer quotient already. So here are a couple more arithmetic operators. And I don't want to spend a lot of time talking about them. So we have the exponent operator, which is double asterisk. There is an up caret operator in Python, but it's not the exponent operator. And the remainder operator, which is the percent symbol on my keyboard. This is also called the modulus operator. In the United States specifically, we have a concept called division with remainder that we learn in elementary school. If you didn't go to elementary school in the United States, then you might not call it that. You might call it something else like modulus. If you don't care about it, you don't have to learn it. It's not going to be important today. But you can take a moment to try some of those other operators if you want. Would anyone like to share an experiment that you did with one of these more arithmetic operators? Okay, so we have a suggestion from the Zoom chat. I'll drop that into my notebook. So we have three double asterisk 2%2. Okay, I will try to interpret that. I think that exponent comes before modulus in the order of operations. So I think this is 3 to the power of 2, which is 9. And then modulus 2. So the modulus of 2 is if you divided by 2 and then rounded down to the nearest integer, you would have, and then multiplied by 2 again, then you might be short from your original number because of that rounding down. So by how much how much more than 0 is 9 from the nearest multiple of 2? That's a weird question. So the nearest multiple 2 is 8. If you divided 8 by 2, you would get 4, which is an integer. So 9 is 1 more than 8, and that is why the remainder of division by 2 is 1. Thank you for that experiment, Tom. Okay, so let's start a different topic. Variables. So does anybody remember from your algebra class what a variable is in algebra? So the use case of a variable in your algebra was to represent an unknown value if you're solving an equation, or a family of values if you're writing a function that you're going to graph. So something like 2x equals 4 would be an equation that you need to solve. So x represents a specific unknown value. And then in an equation like y equals 2x plus 1, then x and y both refer to a family of values, and you're going to graph a sample of them. In programming, variables do something similar, but not exactly the same. In programming, a variable labels a specific value, one specific value, but it's not an unknown value. The value will be determined when the variable is created. So the main use case of variables is to store data that you can refer to by a label, so you don't have to memorize the value of the data. And that means if your data changes, your code doesn't change. You get to use the same label to represent different data if the data changes. So variable names are combinations of characters that don't get recognized as one of the data types, and they will be color-coded black if you are in the light theme. They'll be color-coded white if you are in the dark theme. And there are rules about what you're allowed to name a variable, but they're really boring, so I'm not going to talk about them. Eventually you'll just get an error, and then you'll have to wonder why it's an error. So in order to create variables, we use the assignment operator, which is the single equals sign. The single equals sign looks kind of similar to the equation that we were talking about from algebra, but it doesn't do exactly the same thing, because in algebra, the equation is a problem for you to solve, and in programming, the single equals sign just creates a variable. That's all it does. You can't use it to solve complex problems. So we have to also keep in mind that double equals is a conditional operator and single equals is an assignment operator. They have to be different because they do different jobs. One creates variables, the other is creating Booleans. So after you create a variable, we need to be able to inspect it to see what data is stored. And so the print function is one way to do that. So if you use the word print and then type the name of a variable, then what appears in the output of the cell will not be the name of the variable, but instead will be the value of the data that variable represents. So let's do the hello world exercise, but instead of print hello world, let's do print my variable. You can name your variable what you want. So I'm going to do this exercise myself as well. So I have to replace what's missing from this code. This is a incomplete code cell. You have to fix what's missing. So on the left, I'm going to change it to Richard's variable. I'm not using an apostrophe because apostrophe is one of those characters that's not allowed in a variable. So Richard's variable equals hello world. Hello world is a string. So on the left, you type the name of a variable you get to pick, and on the right, you put any kind of data you understand. And then we're going to also type the name of the variable in the print function's parentheses, Richard's variable. So when I execute the cell, Richard's variable is not what appears in the output of the cell, but instead, hello world is what appears in the output of the cell. Please do take a moment to try that. You can replace this with not a string, but some other kind of data, you know, perhaps a number like 5. And now 5 is in the output of the cell. Okay, so let's learn some more things we can do with variables. So far, we've seen the assignment operator where the name of a variable appears on the left. Also, we need to know what happens if the name of the variable appears on the right. So when the name of the variable appears on the right side of the assignment operator, then you're not creating a variable. Instead, we're using the variable that already exists to retrieve that value from memory, substitute into this location in the code, and then continue to evaluate the operators. So in this code cell, I create 2 variables named principal and rate. And then I have another statement that is interest equals principal times rate. And of course, I don't mean take the letters in the word principal and somehow multiply them, because that doesn't make any sense. What this means is go to memory, find what value principal represents, substitute that here. So it's 500 times 0.05. But I never typed 500 times 0.05. So if I change the numbers, this statement will read the same, but the result will be different. And then after evaluating all of these operators, finally, you get down to one piece of data, and then you evaluate the assignment operator to create the next variable, which I have named interest. And then so when I print interest, I get you earned 25.0 interest. Also, another thing is you may notice I put a comma in the print statement. We will talk about the commas later. For now, it's just a way to print more than one thing, so that we can make the output of the print a little bit more exciting. So if we change these variables up here, the output will be different, even though I never touched the line of code that generates that output. So the power of variables is you can reuse your code with different data. You don't have to write all new code. That's the point. Any questions about variables so far? I didn't see a question yet. How about your exercise? You do a calculation with some variables. So if they are numeric variables, you can do arithmetic. If you wanted to do a calculation with a different type, you would just use the appropriate operator that works with that type. So we know some operators for working with strings and booleans. So if you don't want to do numeric variables, that's fine. You can use your strings and booleans, use your strings and booleans operators instead. The point is, I need you to write variable equals and then an expression involving operators and variables, so you can demonstrate retrieving those values from memory and using them in a statement with operations. So Eric asks why having the word print interest and the word interest by itself are giving the same answer. The reason for that is that if putting the word interest by itself is a special case that only works if it's the last thing in the line. So here I'm adding the word interest as the last thing in the line, and you can see that the output will include that value. But if it's not the last thing on the line, if I put it somewhere else, then it has no effect. This is valid Python. It just has no effect, because printing the description of the thing is a special case for Jupyter that's only for the last line of the cell. So if you want to print more than one thing, at least some of them you're going to have to use the print statement. The print statement works no matter where it is in the cell. So if I execute the print statement twice, I get 2 lines in my output. But if I just have the word interest twice, only one of them will be in the output. There are also some cases where the data is very complex and printing it will give a different result than putting it at the end of your cell. So sometimes which one you want depends on what you actually want to learn about that thing. Did anyone do an exercise calculations with variables that you would like to share with us? Havila has shared some code, so I'm going to copy and paste into my notebook so we can see what the code does. So we have A and B, and then we have an expression involving multiple copies of A and B. That's exciting. And some arithmetic operators, and then printing the answer. I don't know what the answer is supposed to be because I don't know what A, B, and C mean, but it looks like valid Python to me. Thank you, Havila, for sharing your exercise with us. It is 12:29. I don't think we have enough time to do anything more before our lunch. And I think we definitely need a lunch because your brain probably needs a moment to process the concept of variables. So let's take our lunch break. Hey, students. Do you remember we were just learning about variables? It's time to learn some more about variables. So, by a happy coincidence, the topic we're going to do right now is inspecting variable types, which can help us to learn about variables that we may have forgotten, or maybe we never knew what data was in there. So it's the perfect exercise for coming back from a break. So we previously used the type function to inspect data. You can also use the type function to inspect a variable. So your exercise is to create a variable and then use the type function to get the type of the variable to confirm that the variable stores the same type that you think it does. So for example, if I have my variable equals hello world, and then I execute type of my variable, the result is str. The variables know the type of data they refer to. I would like you to try variables of different types. So do you remember any other types of data that we learned today? William says float. Okay, so I could put a float in here. And we see that the type of my variable is now float. And Eric said something about a list, so I could put a list in here. And the type of that is list. And I could have my variable be the print function and the type as built-in function or method. And I could have my variable be the word str, and the type of str is type. Are there any questions about variables or using the type function? Would anyone like to propose a quick exercise using variables to jog your memory before we move on to the next topic? I didn't see any response. So I guess that means you want to move on to the next topic. I suppose I should ask people if your notebook is still running. So if we hop on over to my interactive sessions page in the portal, and there's a button for that. If you're looking at the hotbar, my hotbar turned vertical because I made my font too big. The toolbar at the top of the ACES page has a 2 squares icon, which is the My Interactive Sessions icon. And clicking on it will take you to the page where you can see the card for your running job. Mine says time remaining 2 hours and 51 minutes. That's definitely long enough to finish this course. So if I have a running notebook, I could return to it. If it's not open in a tab, we'll just reopen the tab. So how about our next topic, functions? We've actually seen 2 functions already. We've seen print and we've seen type, which are for inspecting data. But the majority of functions are not for inspecting data. The majority of functions are for transforming data. So in algebra, a function takes an input and produces an output. That is the most common type of function in programming, but other functions are also possible. So in programming, the input to a function is called an argument, and the output is called the return. So functions relate to the programs because they can take input, they can produce output, and if a function does both of those things, then we say that function transforms data. In addition, functions can also have side effects, such as modifying what's in memory or taking an action. So the print function moves data to the output of the cell, which is not the same as returning, because the data is not doesn't stay in the code to then have further operations. So let's start by talking about the argument. So if a function has an argument, then it accepts input data, and the argument goes in the parentheses. So an argument often requires a specific type of input data. We previously saw the print function, which is an example of a function that does have an argument. And when we provide the input data, hello world, then the data was sent to the output of the cell. But the print function does not have a return. So let's talk about what we can do with functions that do have a return. We can assign the result of a function to a variable. That's the most common thing you might do with the return of a function. So if a function returns, then the output takes the place of the function on the line where the function was, and then you continue evaluating the rest of that line. So after the function is executed, the value can be stored in a variable. So here's a function that returns. It's the length function. len is a length. We'll count how many characters are in a string. And then the result is a number. And because the length returns its result, we can capture that and assign it to a variable. So I named my variable length of hello. I can then print that variable. So it says 5. There are 5 characters in hello. 1, 2, 3, 4, 5. Counting the number of characters in a string is okay, but you know what's really fun is a function that produces any possible string. So that's the user input function, which is input, and input has an argument, which is its prompt, and the prompt is displayed to the user. Then the user enters text. The text the user enters goes into the code and is returned. So that means it can be captured in a variable. So here's an example of a code cell using the input function. There's a comment getting user input. And then we have the line username equals input. What is your name? And here's a funny character, \n. That's the shortcut for the new line character, which is sometimes easier than putting a string that is actually a 2-line string. If you don't want to write a 2-line string, that's a shortcut for giving you the extra line. So the prompt is what is your name? Then it will store the result in username, and then it will print out the greeting. Hello, username. Let's run the cell and see what it prints out. What is your name? And now there's a box for me to type. What should I type? I'm confused. So I hit enter and it says, hello, confused. Oh, great. My code is a dad. It's telling dad jokes. I am also a dad. So that's why I know about dad jokes. Dad jokes are the lamest possible jokes you can imagine. So you should definitely try the input function because it's fun. So first try the example where you run the cell, and then if you run it again with the same code, the different output. So the first time I ran it, the output was hello confused, and the second time I ran it, the output was hello Richard, but the code was the same. So that's the power of variables, which is the same code with different data, different result. So let's give you a minute to try it. Please use the input function to get a string from the user, combine that with some other text to print out a message. So there's more than one way to combine strings. We've seen the concatenate operator. We've also seen printing multiple strings with the comma separating them in the print function. So you could try one of those. Oh, William is asking a question. What if you want to put other characters in the prompt? So within strings, \/ is the escape character, which means it doesn't represent the \/ character itself. Instead, it modifies the next character. So you can perform, you can either use it to insert special characters like new line, or you can use it to prevent special characters from being interpreted as special. And if you want to print the backslash itself, then you use double backslash, where the first one is the escape character and the second one is being interpreted as a normal character instead of as an escape character. And Kasoon asks, how can we input something that's not text? You can input something, the input function only accepts text, but you can convert text into other types, which is a good use case for what's coming up in the next section. So let's, I'll show you an example of how to convert. So user count, user integer equals input int please. But additionally, we have to wrap that in a function that converts a string to an integer. And then we can check its type to make sure it's actually an integer. So if I put 4 in there, then the type of 4 is an integer. But even this won't save you from bad users. If they put text in there, it just makes an error. So bad can't be converted to an integer, so the program just crashes. Womp womp. The tech here is using the integer function to transform text into an integer, but it only works sometimes. So if you need to transform text into numbers and it's coming from the user, you're going to need a more robust strategy than this.
So I started to help. I didn't realize that the tough was played, but not until I pulled really tough.
I think Joshua is trying to say something, but I couldn't quite hear it. Is my volume down?
It was background noise. You can continue.
Okay. So I can tell you about lots of different functions, but if I tell you, you'll probably just forget. So tomorrow, if you want to use a function, how do you know how to use it? Does it have arguments? Does it return something? You need to know how to find out. So we have the help function. The help function takes as its argument the name of a function, not the parentheses. So if you put parentheses after the function, you're executing the function. We don't want to execute it. We just want to refer to it by its name. So it's help name of a function. And then the output of that will be a string that describes the function. There's another way to get information about functions, which is the question mark operator, that will also give you text, which tells you something about the function. They're not quite the same, but they both can be helpful. So the help function is a generic Python thing, and the question mark operator, I think I'm not sure if that's a generic Python thing or if that's specific to Jupyter. I don't know. I pretty much never use this one. So here's a function, ABS. How do you know what it does? Let's find out what it does. So first you type ABS. How do you know you've spelled it correctly? We have the tab key, which will give you the autocomplete pop-up to suggest these are the things you might be trying to spell. Yes, I'm trying to spell ABS, so I've spelled it correctly. Notice if you do AB tab, it doesn't suggest anything else. Apparently there's no other functions that start with AB. So ABS is the name of a function. So how do we find out what it does? Let's try the help function. So we'll call help on ABS and the text comes out. Help on built-in function ABS in module built-ins. ABS, and then it describes what kind of arguments it has. So it has an argument, which is named X, and it also has the thing named this slash here. The slash just means no more arguments. Some functions can have multiple arguments, so the slash is here to tell you no more, just the one, please. And then the description of what it does. Return, that's a keyword. That means the function outputs a value. So now that we've read the help function, please do an experiment. Try to use the ABS function with the parentheses to see if you can predict what it will do.
I might beat Valentine.
Does anybody have a guess what ABS is going to do? So absolute value is a math thing. So we should put a number in there. So ABS of -9 is 9.
Can I ask a small question about the previous thing that you showed, or would it be better to ask it later?
Is it about help or ABS?
No, it's just about the input function.
Input. I think we should return to input later.
Okay.
Input is not a simple function. We should learn some simpler functions first. We can return to input later. How about we continue to learn about some different functions? So the range function is a function that we will use later. So we should discover it. So if you start typing range and hit tab for autocomplete, are you seeing my pop-up? That happens when I hit the tab key. So I hit tab for autocomplete, then I can autocomplete to range. And then we need to learn about it. I used help last time, so this time I'm going to go with the question mark. It says that range has two different ways that it has arguments. So you have this first one where it has one argument named stop. And then you have the second one where it has 3 arguments named start, stop, step. So range can have 1 or more arguments. Range produces a sequence of integers. And it looks a bit complex. It's got more than 2 sentences to describe it. So maybe it would be better to just try it and see what happens. So we know that it can take 1 argument. So try the 1 argument style first. Range, and then put a number in there, like 5. So the output of range 5 is range 0, 5. That's not very interesting, is it? What if we have multiple numbers here, like 5, 6, 7? Okay, so if you input range, the output, if you give range some arguments, the output is just the same thing. But we want a sequence. How do we make this actually give us the sequence? Okay, so we're going to have to use the print function, because currently just displaying the output on its own line is not telling us what we want to know. So let's use the print function. And the print function uses something called, we can use something called an unpacking operator to get the sequence. So let's do range 5 again, but we'll print it and we'll use the unpacking operator. And now we see 0, 1, 2, 3, 4. We almost never use the unpacking operator because this isn't the correct best way to use the range function. We'll be using the range function in a different context where we don't want to print it. But sometimes you want to print it, and that's when the unpacking operator is helpful. I think I would like to move on because you can see there's a lot of exercises here about range, and we don't need to learn that much about range. I think it was fine to show it, but I would rather move on and learn a new topic. We'll get more experience with range later. So let's learn a new kind of object called tuples. We recently learned variables, which are, you can label one piece of data. A tuple is a simple way to combine multiple objects. So the comma operator combines multiple objects into a tuple. If you combine multiple data on the right side of the assignment operator, you can store that into a variable. That is called packing. You can also do the opposite. If you have a tuple, you can assign each of its pieces to a separate variable on the left side of the assignment operator. So the multiple variables on the left side of the assignment operator is called unpacking. You can do packing and unpacking on the same line, and that allows you to assign multiple variables at once, which is occasionally helpful. So here's an example of a tuple. Words is a variable, and then I have a hello, comma, my, comma, friend. So that's 3 strings separated by commas. The commas are packing these strings into a tuple. So we'll print to investigate the type of the variable words, the length of the variable words, and the contents of the variable words. So after I hit run, I have the type of words is a class tuple. Its length is 3. 3 is how many data there are in there, not how many characters are in the string. We previously saw length on a string, so the length of hello was 5. When you do the length of a tuple, it doesn't matter how long the strings are, only how many of them there are. And then finally, when you print words, it gives you hello, my friend, separated by commas, and also there's some parentheses to help you see which is the first and last item on the tuple. So an exercise for you is the multi-assignment. Create 2 variables at once, but only type the equal sign once. So you have to use commas to do packing and unpacking on the same line to assign 2 variables. And they can be different types. They don't have to be the same. So one could be an integer, the other could be a string. And then I suppose you'll need to print them to verify that they got the correct data. Would anyone like to share what 2 values you want to assign to 2 variables? Okay, no suggestions yet. I will think of my own suggestions. So I'm going to do A and B are 5 and false. Then I'm going to do print A, print B. Whoops, typo. Print B. So A and B are just 5 and false. This isn't usually useful. It can occasionally be useful, but the point is that on the next exercise, I'm going to show you when this is really useful. And that is unpacking functions. So some functions return a tuple as their result. So here's the example, the div mod function. The div mod, so we previously saw that there's two kinds of division. We have the single / division, and we have the double / integer division, and then the double / integer division is paired with the modulus operator, which is the remainder after performing the 2 slashes integer division. So if you're not doing floating point division, if you're doing integer division, there's really two results from doing integer division. You have the whole part and you have the remainder. So what if you want both of those? Do you have to type both operators on separate lines to assign two variables? A bit tedious, isn't it? So the div mod function is the shortcut. It will compute both the integer division and the integer modulus at the same time and return both results. That means we have to save two results from a single expression, which means we need tuple unpacking. So if I go result equals div mod 5, 2, and then print result, what will I get? I get 2 and 1. So 2 is the integer quotient rounded down, and 1 is the remainder after you round it down. Well, what if I want the 2 and the 1 as separate variables? Then you just unpack the tuple with a comma. So A and B. Then you can go print A, print B. Now the 2 and the 1 are stored in separate variables. So this is the main use case for unpacking tuples. Sometimes functions return tuples, and you may want to hold the tuple in a single variable, or you want to maybe want to break the tuple up into separate variables. Eric is asking a question that looks like he's thinking about lists. There's more than one way to get the second value. So one way is to do tuple unpacking, where you use this placeholder variable underscore. Underscore is this placeholder variable that says, this is going to be one of the spots where one of the elements of the tuple goes, but we're not going to bother to actually assign it to a variable. So you would do it like that to capture just the second one. And the suggestion of having the tuple, and then if you have a tuple, how do you extract one item from a tuple? That's a topic for another day. There is a way to do it, but we're not doing that today. Today we're just looking at tuples because we might need to use them sometimes. Multi-line statements. So far, every line of code we've written has been all on one line. And therefore, every line is a separate piece of code from every other line. But sometimes if you do it that way, your line will be very long. And it's more readable if you could break it up. So Python will sometimes let you break up your code onto multiple lines. And a common use case for this is if you have a function with many arguments, then it might get very long. So you could have the function name, And then you have the first argument, which could be an expression, and then the second argument, which could be a really long function, variable name, and then you have a few more of those. And before you know it, you're off the end of your line and you can't read it anymore. So being able to split up the arguments of a function onto separate lines helps with readability. So there's a rule in Python that when you open a parenthesis or a bracket or a curly brace, then the end of the line does not terminate the code statement. The code statement cannot terminate until you get the closing parenthesis or bracket or brace that pairs with the opening one. So the new lines that normally cause the statement to end don't cause the statement to end if you're inside of a paired, these paired symbols. So the example is the print function. We know that the print function can have many arguments. So if we have print function with parentheses, and you start doing things like 1, 2, 3, and it's getting really long, and you don't want to have them all on a line, you can just hit enter. And now the arguments are not all on the same line anymore. And the reason this is valid is because of the parentheses. The parentheses that are part of the function do count. Also, the parentheses from arithmetic also count. So, and also the parentheses for making tuples, which sometimes you see, those also count. So this is valid Python. If we run it, we will get our 1, 2, 3, 4, 5. And they come out on the same line in the output because the print statement doesn't care where they were in your code. It just cares how many of them there were, and it's going to try to put them all on the same line in the output. So here's another quick tip. If you've got two parentheses, it doesn't have to be inside of a function. If you've got two parentheses and they're empty and you hit enter, then you see what happened. I only hit one key on my keyboard, but I got a whole bunch of results. I got a new line, a bunch of spaces, and then another new line, and then the cursor stayed here. So this is Jupyter Notebook, the IDE, trying to be helpful because it knows that it will be more readable if you do it like this. So the parentheses are vertically aligned. So when you see this one and you go, where's its partner? You just track down with your eye. Oh, there it is. So it's much easier to find its partner if they're vertically aligned. So that's why Jupyter Notebook does it this way. And then you can put your whatever you need to do in here. Did everybody get a chance to do a print statement with multiple arguments on separate lines? I see a green check mark. Okay, so a similar exercise is a multi-line tuple. So you need to assign multiple variables, but this time you can split up the values and the variables on separate lines. And the way that that works is because you can always add parentheses to an expression just for the order of operations, you can put the parentheses around your comma separated tuple, and then it becomes a place where you can hit enter and get a new line. So previously I had a comma b equals like 1 comma 2. You cannot put those on separate lines yet because there's no parentheses. But if we add some parentheses, which don't have any effect on the code because they're just there for order of operations, now you can go ahead and put some new lines in there. I don't think there's too much of a use case for that. I'm just kind of getting you in the habit of how do you read multi-line code? Because you're going to occasionally see multi-line code in the wild. It happens. You don't want to be terrified of it. It's not that scary. We're just taking advantage of the feature of parentheses to put things on multiple lines. I guess I need a print statement, right? I need to do like print A, B. There we go. Otherwise, you don't really know if it did anything. Okay, so we've been working for about 40 minutes after we resumed after lunch break. I think I would like a break for myself because my brain needs a little bit of a rest before we start the next topic. 40 minutes isn't a long time, but at the end of the day, I don't work as well at the end of the day, you know? So in the morning, I can go for hours. In the afternoon, I can't go for hours anymore. So I'm going to call a break, at least 5 minutes. Can I have 5 minutes? Let's say I give myself 5 minutes. Howdy, students. Welcome back from my brain break. So next, we will open the third of the notebooks for today's learning, and that is the control notebook. I've also posted a link to a Google Colab copy of this notebook if you happen to be working in Google Colab instead of the ACES portal. So now I have Python for New Programmers presented by me, Control Structures. In this lesson, you will learn about flow control, control structures, loops, and how Python uses whitespace and blocks. So a while ago, someone asked me a philosophical question. Is there more than one way to do things? And for Python, the answer to that philosophical question is there is one best way to do things. So a question you might have is there more than one way to style your code? And in Python, the answer is there is one best way to style your code. So we're going to learn how Python requires us to style our code for form and function. So the word of the day is indentation. Indentation is the amount of white space at the beginning of a line. So white space characters includes spaces, tabs, a few other funny things, but tabs are weird. So we're going to stay away from those and we're just going to count spaces. So common indentation levels are 2 spaces, 4 spaces, 8 spaces, but Jupyter Notebook doesn't like 2 spaces because it's hard to see 2 spaces. They're kind of small. So it will encourage you to change it to 4 by coloring it red. Technically, that is a style choice. Python doesn't care. Python says 2 is valid. Any number of spaces is valid. So the indentation level will be the number of spaces. What do we use it for? So in Python, programs are structured into blocks. Many programming languages have a concept called a block, A block is simply a group of statements that are executed together. So in Python, the way that we notate a group of statements that are to be executed together is all of those statements have the same indentation. So you can see in this little example here, we have two blocks with no indentation. Sorry, two lines with no indentation that are part of block 1, and two lines with some indentation that is the same are part of block 2. That's actually 2 spaces if you count them out. Okay, so a block is executed together, but that means we need to know when they will be executed. So a control statement determines when a block is executed. You can recognize control statements because they end in a colon. They precede the block that they control. So they're not part of the block they control. That would be redundant. So the control statement that controls block 2 cannot be part of block 2, so it is part of block 1 in this example. So there are many different control statements. Today we're going to focus on just the simplest ones that you'll use all the time. So the first control statement we're going to learn is the loop control statement. So Python has a loop control statement named for. The for control statement will execute its block some number of times. And each time it executes its block, there is a loop variable that's keeping track of the iterative procedure. The value of the loop variable changes each time the block is executed, so you can distinguish one execution from another. After you execute the block, you go back to the control statement to determine whether the block will be executed again, and assign the loop variable, and then execute the whole block. Eventually, you run out of values in the sequence. You get to the end of the sequence, and then the control structure will skip past the block to whatever's next. So here's how you write a for statement. For variable, you can pick whatever you want for the loop variable. The word in, which looks very similar to the in operator. It's not the in operator. We're overloading this word. This is the in keyword that pairs with the for keyword. And then you have an iterable. An iterable is something that generates a sequence of values. Now, it could literally be just a handful of values. Like we saw a tuple. Tuple is valid. It could also be the range function, because the range function generates sequences of values. And there's a whole family of things that can be the iterable, but for now, we're just going to focus on things we've already seen. So the simplest thing you can do with a for loop is define how many times you want it to execute and just execute the block that many times. So that's repetition. So the way you do a repetition is for variable in range count. Count is an expression. It could just be a number like 5. And then the for statement will execute its block that many times. The block goes after the control statement, and all the lines need to be indented the same amount. So let's do an exercise. We previously did hello world. Now I've written a program that contains the hello world program, but also a for statement. So let's read this code. for x in range 5, colon, indented, print hello world. So x is a loop variable, but it's not being used anywhere. We just need to pick a name. Range generates a sequence, and it's going to generate 5 items in a sequence. Therefore, the for loop will execute its block 5 times. So we're going to get hello world 5 times. You need to edit the code to make it print whatever phrase you want 10 times. So how about hello, Richard? And I'm going to change the 5 to a 10. Hello, Richard. Hello, Richard. I'm not going to read all 10 of them. So here's an interesting question. How do control statements interact with variables? So if you have a variable that was created before the control statements block, for example, here I have a variable named total, and then inside the control statements block, I wish to use that variable, what will happen? I ran the cell, so it kind of gave away the answer. You just have to mentally imagine executing this block multiple times. So total is 0. 0 plus 1. Store that back in the total. That will be 1. 1 plus 1. Store that back in the total. That'll be 2. So the total is getting incremented by 1 each time it gets executed this line. But the initial value was 0. What if we change the initial value? So if the initial value was 10 when we created this variable for the first time, and then we execute the code, we add 1 repeatedly, and from 10, now we reach 15. So the variable total that was created outside the loop does exist inside the loop and continues to behave like a normal variable. We can use that to do some calculations. So I previously showed you the calculation for the interest using the principal and the rate, but that was a one-time interest calculation. What if you have compound interest? Then you need to calculate the interest over and over again, and each time you add it back into the account. I think Albert Einstein sometimes once said that compound interest is the most powerful force in the universe. And that's funny because he literally wrote a theory of gravity, which is an actual force in the universe, unlike compound interest, which we just imagine in our minds. So I would like you to take a minute to try to solve this exercise. Recall the formula is account equals account plus interest. And also you need interest. Interest equals account times rate. And I guess you need an initial account value, like maybe 100. You can't start with an empty account because, you know, the interest on nothing is also nothing. So now we just need to write the rest of this code. How do you feel? Do you think you could write the rest of this code? I put it in comments because I'm not sure where it's going to go in the code. It might go here or might go somewhere else. Any suggestions from the participants where I'm going to put this code in my program?
You're going to need to create a for loop.
Right. Where do you want me to put the word for?
You would put it between so the first and second lines, basically. You're going to start.
I need a new line. And
Yes.
for. Okay, and does anybody want to tell me what I should write for the rest of the for loop statement? There's more than one word in a for loop, right? I could go grab one of these. Should I just grab this guy? Okay, I grabbed it. Is my code done? If I uncomment these, will it be done? Who thinks it's done? Who thinks it's not done? I realize that many of us are experienced programmers and you probably can already see the solution. That's fine. It's great if you can see the solution, but some of us are new programmers and you might have to think about it for a moment. This is not a trivial program. There's at least 4 lines of code already. We might need a 5th line of code. So how do I make the loop control these lines of code? Currently, what's it controlling? The name of the game is control. Remember at the beginning? Control. Somebody makes a decision and somebody else obeys that decision. That's what control means, right? We need for to make the decision, and we need these lines of code to obey. Well, are they currently going to do that?
You commented
I'm
it
waiting
out.
for someone to tell me the keyword. The word is indentation. So if we just run the code, watch what happens. Oh, incomplete input. Why does it? Okay. I just needed something else. Okay, so if you just run the code, I just put print there because I needed another line because it was like, why are there no more lines of code here? So print is just a dummy line of code I wrote. And we get indentation error, expected an indented block after the for statement on line 2. So here's the for statement on line 2, but I didn't put any indented blocks. So how do I turn this into proper indented blocks? Anybody have an idea? Nobody wants to tell me an idea. Very sad.
Uncomment it and add 2 spaces.
2 spaces? That looks okay to me. I previously said 2 spaces is valid. And is the program finished? Should we run it like this? Oops, I forgot rate is not defined. I guess I should define rate. Who would like to pick where I define the rate? Should I just replace this with something else, or should I make a variable? I want to make a variable. You know what I want to do? I want to define both of them on the same line. That's fun, because I'm using the tuple. So the account and the rate I'm defining on the same line. Yay! My code works. Look, it's working. 8, 9, 10. Every time I click run, the number goes up. My code is working. It's not very exciting though. There's no output. Can I get some output? Who would like to suggest a way to make my code have output? Anybody have a thought? What output would you like to see from this code?
Print the account value.
Print the account value. Yeah, that's reasonable. So after 5 iterations of 5% interest, I made a little over $27. Would anyone like to suggest changing these numbers to see what happens? It's not really code if you change the numbers. It's just for fun. So if I make this 30, what is that? 30 years. So you put $100 away for 30 years, it turns into $400. That's not the worst. %5 interest for 30 years. That's very plausible. So you can multiply your money by 4 just by doing nothing. Fantastic. Okay, so this is like, I guess, okay, but something's missing because I still haven't told you what we're going to do with this variable x. It's just kind of sitting there looking funny. Haha, I'm here. So let's do something with that. So instead of repetition, let's do sequences. A sequence is when the lines of code are executed repeatedly, but each iteration of the loop is slightly different. So how do we make it slightly different? Well, we're going to change the value of a variable. So we have the loop variable, which comes after the keyword for, and it's going to be reassigned to each number in the sequence. So if we've got a range function, the range function produces a sequence of integers. So let's use the loop variable in the block. So we have x as our loop variable, and in example loop variable code cell, now the letter x appears in the block in a print statement. So what's this going to do? It prints the character x in quotes, so that's not a variable, and then it prints the value of the variable x. And we get 10 outputs, 0 through 9. So range 10 produced the values 0 through 9. Some people might say, oh man, that's kind of disappointing. I wanted to see the number 10. And why is there a 0? Python is a language that is called a zero-indexed language. That means every sequence will start with 0. Not all languages are this way. I think, for example, MATLAB and R are 1-indexed languages. Sequences start with 1. And in some sense, that's a preference thing. But there are valid reasons to have a 0-indexed language that we will see next time you join me when we start looking at data structures. For today, it's just a style choice. So what can we do with a sequence of integers? We can transform the integers into something fresh and new. How about square numbers? Who knows about square numbers? The square number is a product of an integer in itself. So 5 times 5 is 25. 25 is a square number. So your exercise is to print out a whole bunch of square numbers. But nothing, no other numbers. Print out only square numbers. Do you have an idea what to do? I'll give you a hint. You start by copying this code, you put it here, and then you think about how to change it. So how do we change this code so that it prints out square numbers? Any thoughts? Anybody want to
For
speak up?
X, you can add asterisk 2.
Ah, like that?
To the variable.
Ah, like that? Ooh, hey, I know these guys. 1, 4, 9, 16. These are square numbers. Congratulations, Sarah, you solved my problem. Edita has also solved the problem. Edita, you didn't use the 2 asterisk. You did something a little different. Do you want to tell us why you picked that one? X times X. That is another way to compute a square. That is valid. So how about a sequence that's not an integer sequence? Can you have a sequence of something else? Yes. So we've actually already seen a couple of types of variable that can represent a sequence. So the first is the string, which is a sequence of characters. So can we use a string as a sequence of characters to populate the loop variable? Let's try it and see what happens. For C, in hello world, print C. And what do we get? We get hello world, but now all of the letters are on a separate line. Does anybody know why I chose the letter C for this variable? Can you guess why I picked the letter C? C for character. Yep. I'm not that creative. I just did what I thought was obvious. So what can we do if I give you a sequence of letters one at a time? You know what would be fun if you were attending a football game and the cheerleaders are feeding you a sequence of characters one at a time. They might do that by saying, give me a, and then a character, and then you have to repeat that character back to them. And after they've given you enough characters, they will ask you what it spells. And it will be something fun, like the name of your team. And that's a way for the audience to participate in a football game that would otherwise just be sitting in the stands. The cheerleaders can make it more interactive. I also have an image of a cheerleader. If you're working in Colab, you might not have the image of the cheerleader. And I apologize for that because I didn't have time to plan for that. But you can see on my screen, it's just an image of a cheerleader. So let's create a cheerleader pattern. You feed, give me a letter, then the letter to the audience, and then you ask the audience what it spells. And the for loop is going to generate most of those lines. So let's say that the message is a string, and I'm attending Texas A&M University, so we've got some catchphrases, and one of the catchphrases is gig 'em. So I'm going to choose that to be my message. And now I need a for loop for C in message. Print. Give me a C. And then after I've printed all those message lines, I have to ask the audience, ooh, here's a fun one. Input. What does that spell? I don't know what I'm going to do with the input. I got ahead of myself here. Let's just pretend the user is correct. We can come back later and fix it if the user is wrong, but for now, we'll just assume the user is correct. Give me a G, give me an I, give me a G, give me a space, give me an apostrophe, give me a he, give me an M. What does that spell? Food. That's right, it spells food. Okay, I'm just kind of having some fun here. The point of the exercise was to use the letters one at a time in some line of code. So instead of having to write all these lines of code, I just wrote one line of code and I use it multiple times. You could change the message. Howdy. Give me a howdy. What does that spell? Howdy. And would anyone like to share your code? Joshua would like to share Python, and you added in some more control. We haven't learned that control structure yet, but we might learn it later. So very soon we'll be able to understand Joshua's response. So we'll save that for later and come back to it. I'm putting your response here, Joshua, so if we come back to it later, we'll get a chance to understand what it means. So let's try tuple iterable. So we did the string. Another thing we know is that a tuple can have multiple values. So we can use a tuple to define the sequence for the loop variable. So here's an example for item in banana 100 false print item. And what comes out is banana 100 false. When the type of the variable is not the same every time, it's very difficult to write useful code. What code can you write that will be valid if the variable is of an unknown type? That's hard to do. Print, you can get away with a print statement, but that's about it. So another thing you can do is you can print the type of the item, because no matter what it is, you can always use the type function. So your exercise is put multiple elements in a tuple and then get all their types and print those. But of course you want a loop so that you don't have to do the type function by hand a bunch of times. So that's an exercise I'm confident you can do. Please take a moment to do that one. Or if you don't want to, maybe find another way for a tuple to be fun. Or color in red, orange, yellow, green, blue, violet, do, print, rainbow has color. Rainbow has red, rainbow has orange, rainbow has yellow, rainbow has green, rainbow has blue, rainbow has violet. I'm a rebel, so I don't always follow the instructions. Sometimes I want to do a different code instead. Sagnick is asking, how long can we have Jupyter Notebook access? So you have access to the ACES cluster for roughly today. If you're through our training allocation, if you have a different allocation, then these notebooks will still be there when you get back. If you get a new allocation and come back, your notebooks will be there waiting for you. If you're not planning to use ACES again, you probably want to download these. I showed you that in the Jupyter File Navigator, there's a nice download option. You can just download these files. They're just normal files. The images are in here. If you're comfortable with like oh, you know what? I think we've got them on the website now. Events, training courses, this course. It's not on the website yet. We were planning to put the notebooks here as well, so you can upload them to Google Colab or whatever your other favorite IDE is and keep trying on them. So probably later that will be there. There's nothing in the notebooks that makes them specific to the ACES cluster. So you can run them on a different machine if you like. But if you are going to come back on another day to learn more Python from me, the notebooks will still be here when you get back. We don't delete your data. Even if you don't have an allocation for some period of time, your data will still be there when you get back. I don't recall if we advertised the date of part 2, but it has been selected. So Josh, can you please drop in the Zoom chat when the date of the next one will be? Because I forgot. It's in February.
Yeah, let me find it real quick. Currently planned for Tuesday, February 11th.
February 11th is in about 2 weeks, I think.
Yeah.
Is there a registration link available or not yet?
I believe the link is available. We haven't advertised it yet, but I believe you can go there if you want.
If you manually navigate to the course page, somehow there is a registration.
Yeah.
Or you can just wait for the ad to show up on the ACES training list.
I can give you all the link. Give me just a moment. It is a fresh new website, and hopefully it all works. Or web page, rather.
Thank you for attending. I hope to see you again. So for the rest of us, what time is it? It's about 3, right? It's close to 3. So the end of our class period will be at 4. So we should plan for another break between now and the end of the class period. I do not know if now is the best time for the break, or let's do one more thing and then we'll take our break. So we'll take a break closer to exactly 3. So more about loops. We previously used the range function to generate a sequence of integers, but we also saw that the range function can do other things. So let's explore what else we can do with the range function. So range stop produces integers from 0 to stop. Range start stop produces integers from start to stop, but not including stop. And range start stop step produces integers from start to stop in increments of step, not including stop. So for example, if step is 2, then it will just give you every other integer between start and stop. So if you started on even and then you add 2, it's another even. So a step of 2 can be used to generate all the even integers or all the odd numbers very efficiently, because it's just internally adding 2 on each increment. So your exercise is to create a loop of the even teens. So the teens are the numbers that in English end in the sound teen, and that's 13 through 19. So how do we generate numbers between 13 and 19? Well, we definitely want to start at 13 because that is a teen. And we definitely want to include 19 because that is a teen. So that means we should we should be having our stop be after 19 because stop is not included. And we do want to include 19, a valid teen. So the stop should be 1 more than 19 so that 19 will be included. So that means we need our start stop goes from 13 to 20 to generate numbers in the teens. And then the part that is the exercise for the reader is how do we get the even teens? Please do take a minute to try to solve that. Let me know in the Zoom chat if you have a solution and we can share it and talk about it. And that will be our last exercise before we go on break. Howdy, students. Sorry, I got distracted. Joshua has suggested a solution. So let's test Joshua's suggestion. So Joshua suggests 14 to 20, comma 2. So in order to print the even teens, we adjusted the start position to be an even number, and then the 2 step will produce only even numbers. So that is correct. If you left the starting number at 13, you would be getting all the odd numbers. And Eric has showed another way involving another conditional, another control statement that we are about to learn after the break. So I'll go ahead and put that down in our other area for when we come back. So this will be Eric's response. That we will talk about after when we're ready. And now we're on break. Can we get a break slide?
Yeah, sure.
That will be a 10 minutes break. That will be our last break before the end of class. And then we'll try to get through the rest of this notebook until class ends. Howdy, students. Welcome back from your break. We will now continue learning Python, hopefully able to finish this notebook by the end of our class period. Although I am planning to skip a couple of the more tedious exercises, mostly because I find them tedious. But they are available for you if you want to try them anyway. So how about a couple of more exercises with loops before we move on to the next kind of control structure? Loops are fun. So how about loop multiplication? So previously we computed the interest by repeatedly executing a multiplication. But that was a repetitive loop. The loop variable was not involved. So in this exercise, the loop multiplication to compute the factorial, the loop variable will be involved. So it is a loop involving a multiplication and the loop variable. So the reason that a lot of these exercises are about math is because I like math. So if you do not like math, then I apologize. I could have chosen different exercises. But for now, I would like to compute 12 factorial. So the factorial function of 12 is the product of all the integers, at least 1 up to 12. Obviously, you cannot include 0 because then the result would be 0. So how do we compute the product of a lot of integers? Well, we have to have a variable to represent all the integers. So that would be our loop variable. So we have a loop variable. And then we need to have a product, which will be equal to the product that we started with multiplied by the loop variable. So that way, the product gets bigger, and then we multiply the next loop variable, the product gets bigger, and we multiply the next loop variable, and the product gets bigger. So the product has to have a starting value, otherwise this first line will not be defined. So the starting value should not be 0, because if anything we multiply by 0 will still be 0. But 1 is safe enough, because 1 won't affect the result of the product. So this is a few pieces of code. It's not quite complete. Some things are missing, but hopefully you can think about how to complete this code and get the 12 factorial. I picked the word product for my variable because that just means the result of multiplication. You could pick a different word. Perhaps something like subtotal. Total, if you have a receipt where you're doing multiple additions, then the result of each addition is a subtotal, and then when you're done, you declare the last one to be the total. You could do the same thing with multiplication. You could have the result of each multiplication be a subtotal, and then declare the last one to be the total. I don't know if that's valid or not. I'm not the right kind of person to ask that question. You can name your variables what you want. Does anybody have a suggestion for how to solve the loop multiplication and finish this exercise? Joshua has suggested a range function for a for loop. So I named my loop variable, so I'm just going to update that. So now I have loop variable in range 1, 12, 1. Okay, is my code complete? Do I need anything else? Oh, I definitely need some indentation, right? Is this enough indentation, do you think? And I need a print statement. So let's try it. 11. Whoops, I printed the wrong thing. I needed to print product. So the product is huge, but is it the right product? So I can't tell because I only printed the final product. I didn't print anything else. What if we print the loop variable? So the loop variable is 11, which means the last thing we multiplied was product equals product times 11. But that's not 12 factorial, that's 11 factorial. So we needed one more. Alex suggests changing the stopping point of the range to 13. So now we have a new result, which is about half a billion. Is that right? So yes. So the 12 factorial is close to half a billion. And another thing is you have to have your range function have a starting value of 1, because if your starting value was 0, you would multiply 0 on the loop variable and your product would just remain 0, and that's not very interesting. Okay, thank you, Joshua and Alex, for contributing to my solution. So here is loop concatenation, because of course, when you're growing something on a loop, it doesn't have to be numbers. You could grow a string. So we can use concatenation to grow a string, and I've used sum to represent the growing string. That's not great. Maybe I should replace sum with something else. I couldn't figure out a better word. So we're going to pretend sum represents the result of concatenation. So if we execute this cell before you modify it, you can see that we're growing the string A, B, ABC, ABCD, ABCDE. And your exercise is to make it so that there's a space character between all the letters. So how do we modify this to get a space character between all the letters? Any thoughts? This is actually a very simple exercise. You just have to do one small change, but you have to know where to do one small change. So it's more thinking, less typing. What are you thinking? I cannot tell what you're thinking unless you use words. Anybody want to volunteer a response? Joshua suggests an additional concatenation operator between the sum and the loop variable with the one space character string. And now we have grown a string where spaces separate the characters. So I think the main use case for this is if you wanted to have comma separated items in a string. Well, it's a bit awkward because we have that stray comma at the beginning, but the point is that you can take a sequence of things that need to be separated from each other by a comma, and this is one way to add all those commas. It's actually not my favorite way to add all those commas, but we won't learn that until next week. So here we have a section called nested loops, loops inside of loops. It's not very interesting to me because it's just tedious. It's just more of the same. Putting a loop inside of a loop. It's the same thing we already know how to do, but now more of it. So what's different about nested control structures? That's the only part I want to talk about. If you have nested control structures, then the block controlled by the inner control structure has to be even more indented than the block that it is a part of. So this second control structure is a part of this block. Therefore, what it's in control of needs to be even more indented. And for now, that's already enough to understand nested loops. I don't actually want to do nested loops because it's not very interesting. It's tedious. So we're going to skip past that, and we're going to skip past that, and let's learn something fresh and new. Let's zoom down to conditionals. Who's excited to learn conditionals? So we previously learned conditional operators, which are operators that transform values of different types into Booleans. Now we are learning conditional control structures, which is what do we do with Booleans to make them really worth it for us to spend our time trying to understand Booleans? So here's a control structure. The simplest of the control structures is the if statement. The if statement checks its expression to see if it is true or false. And the expression can be a value like true or false, or it can be something that involves operators or functions, and it can be complex. So one thing people do is they'll put multiple data being compared by an operator as the expression, and that all gets evaluated due to order of operations. Finally, it gets coerced into a Boolean, if possible. So remember we learned that 0 and 1 can be coerced into a Boolean. That will come up in this case. So, and then the if will test to see if you have a true or a false. So then the block will either be executed or it won't be executed. Those are the options. So it's very simple. So here's a test for equality. You have to fill in what's missing. So var1 equals, put something, let's say 2 and 3. And we run the cell. And what happens is the end. So the if statement skipped its block because that was false. And we just go to the next one. So the conditional here is doing a lot of the heavy lifting. var1 equals equals var2. The equals is the conditional equality operator that converts these into a Boolean. So if they're the same, the result will be true. Let's make them the same. Now a match gets printed, and then finally we go to the end. So that's not much of an exercise. Let's keep going. So we have if error. So there's a problem with the code, and it's because that the indentation is missing. So originally these exercises were in a different order. So this one we would have done first. That's why it looks very simple. Well, we've already seen the indent error, so we don't need that right now. Let's do some conditionals with arithmetic. So here's 3 variables, allowance, pizza, and tip. If you have an allowance of 20, can you afford to buy a pizza? So you can have pizza if your budget is at least greater than or equal to the cost of the pizza and the cost of the tip. So we have this expression in the if statement, allowance greater than or equal to pizza plus tip. You use order of operations to evaluate this. First, you compute pizza plus tip, then you compare it to allowance. The result will be true if you didn't change the variables. So we'll execute the block. And we have some funny nonsense. So the pizza party is pizza, 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 pizza. So we have here this curly brace. Curly brace is a special character inside of quotes. It can define Unicode characters. So there's a Unicode character for pizza, and one of the ways to specify a Unicode character is to put its label in the curly braces in the string. So if you didn't want the curly brace to be interpreted as a special character for defining Unicode, you would just use a backslash. So actually, I think I'm wrong. I think it's the backslash capital N that's defining that this is Unicode. So we learned that backslash is a escape character. So that determines whether other characters are being interpreted as their normal self or as something else. So we're escaping the capital N. So instead of being a normal capital N, this is being interpreted as we're going to be using a Unicode character from its label. So without the backslash, it literally just prints the capital N and then the rest of those characters. So the backslash capital N is, instead of capital N, let's define a Unicode character. Which one? Slice of pizza. There's actually more than one way to do it. You could grab that slice of pizza and drop it directly in here, because Unicode is valid Python code in strings. Unicode in strings is valid Python code. I don't think you can have Unicode in your name of your variable. Yeah, no, it doesn't like that. But it's okay in strings. Sorry, I got distracted. It's the end of the day. I get distracted very easily. Someone should probably ask a question. Is anybody asking a question about the if statement? That's what's on the menu right now. Any question about the if statement? Would you like to do a different exercise? So that means we're ready to understand Eric's response. So Eric's response for the even teens was for x in range 13 to 20. And then within the for loop, the first statement is a control structure. It's the if statement. And then he computed this math. So what does this math do? Eric, do you want to tell us what this math does?
Sure. It says that if the remainder of the division between x and 2 is 0, then do the following.
So when you divide an even number by 2, the remainder will be 0. So then you know you have an even number.
Yeah.
So you're checking to see if that remainder is equal to 0. I see. Okay, so it's logical. And then the print statement is over here. So you indented it. How many indents is this? 1,
That's
2,
probably
3,
8.
4, 5, 6, 7, 8. So that's 8 indented. So the 8 indented means this block is being controlled by this control statement. And this control statement is part of a block that's being controlled by this control statement. So both of these control statements have to have their chance to make a decision in order to get to the print. And does it work? It does, because it prints 14, 16, 18. Those are 3 even teens. So Joshua's response, actually, we're not quite ready, so I'm going to have to move that down. Sorry, Joshua. But we'll come back to it. So we have more about conditionals. So currently, we know how to handle the case where the expression is true, but we also need to handle the case where the expression is false. So that is what the else statement does. The else statement pairs with an if statement. So when the ifs expression yields false, then it will skip to the else statement, and the else statement will execute its block. So if you have an if-else pair, exactly one of them will execute. What if you have multiple conditions you're interested in? Then we have the elif statement, which is a combination of if and else. So instead of nesting if statements inside of each other and having if, and then your indentation keeps growing, you can do if, elif, and then they are all on the same indentation level. They're pairing with each other. So the way that makes sense is if your conditions are like designed to be exclusive from one another, so you're only expecting one of them to determine the outcome. So when the first if is false, you go to the next. If the next elif is false, you go to the next. And so eventually you get to an elif that's true, you'll execute a block, and that's it. So out of this whole construction, you can only execute one block. The first if that's true will execute, and if none of them are true, then the else will execute. So here we have, do you like soup? And it's an input statement, so you have to run it to see what happens. Do you like soup? Yes. And the response is good soup. Let's try again. Do you like soup? Maybe. I only understand yes or no. So can you explain why the result from maybe was I only understand yes or no? Does anybody care to try to explain your understanding of this? I didn't see a response yet. Let's try some more cases. Do you like soup? No, too bad. Do you like soup? Yes. I only understand yes or no. Okay, what happened that time? Surely I said I like soup, so why isn't it telling me good soup? Ah, yes. Adita correctly noticed that it's a difference of capitalization. Python is case sensitive and also for strings. So if you want to handle uppercase and lowercase, you have to do that yourself by one or more methods. So one of the methods you could do is you could extend the logic. Instead of a single conditional, we could combine multiple conditionals with the logic operators. Let's see how this works. No, but it's lowercase, and now we get too bad. How do you feel about that as a strategy for dealing with uppercase and lowercase? It works as long as there's only one character that could be uppercase or lowercase, because then you just have a single or to handle the two options. But if you've got a whole word that could be uppercase or lowercase, you're going to be in trouble. What are you going to do? Enumerate every possible combination of uppercase and lowercase? That's not going to be feasible. So that's why in 2 weeks we'll be covering some different ways to deal with that that are more practical, which is going to be the object-oriented programming type of way to deal with that. So now that we've seen the else statement, we can go back and understand Joshua's response. Where's Joshua's response? I put it here. So Joshua's response was, if you're doing the cheerleader exercise and you can say, give me a, my original solution was give me a parentheses and, if you recall, it's up here somewhere. There it is. Give me an H, give me an O. And the reason is because I don't know if it's going to be a vowel or not. If it's a vowel, it's an. And if it's not a vowel, it's a. English is weird like that. English is not your first language. I apologize for English. But Joshua was able to come up with a solution. He used if paired with else. So you have a cheer, you have a character, which he named cheer, and then we need to test if that character is a vowel. So one way to test if it's a vowel is to use the in operator to see if the vowel, if the letter you have is equal to any of these members of this tuple. So this is a tuple here. And if your character is equal to one of these, in will result in true. So the in operator allows you to do a lot of different comparisons at once. That's convenient. So then for the case where you have a match on this list of vowels, it's give me n. And otherwise you don't have a match, then if will get a false. You'll skip down to else, and else will execute give me a character. And so Joshua's cheer goes give me a P, give me a Y, give me a T, give me a H, give me an O, give me a N. Well, Joshua, your code is very good. Unfortunately, your English is medium because the rule isn't, is it a vowel? The rule is, does it start with a vowel sound? So the letter N starts with a vowel sound. It's eh. So it should be give me an N. So you want to fix the list to put the letters that start with a vowel sound, which includes a few more than just the vowels themselves. So U goes out because that starts with the consonant sound Y. And then N goes in because it starts with the consonant sound eh. But
And I also realized
that's
you wouldn't
really
cover
tedious.
the upper and the lower case, variants too. So
Yeah, okay, that's even more tedious. Maybe we don't want to do that right now. Maybe we should just finish our lessons for the day. So we were doing conditionals. And we learned more about conditionals. And let's, aside from the cheer problem, which is we've just determined is excessively tedious, let's do something more useful. So how about practice safe division? So have you heard that division by 0 is a problem? If you type 1/0, you get an error. So I don't want to see an error coming out of my code. Code should be error-free. So if your code involves a division, you might need to handle it. So one way to handle it is to have an if statement. And that way, sometimes you perform division and sometimes you don't perform division. Does that make sense? So printing the message error is a stand-in for what you would do if the denominator is 0. It's not the same as your program crashed. Does that make sense? Because if you print error, your program doesn't crash, you can continue to execute more code. Whereas if you just do the wrong division, your program crashes. You're done. You get no more output. So you can see print hello world was never executed. Program stopped on line 2, all done. So the rest of your code is, you might as well not have even written it. So if you want your program to be correct, you cannot allow divisions to occur, divisions by 0 to occur. So you replace that with some other action that doesn't cause your program to crash. So let's practice safe division. You should take a moment to think about that and let me know if you have a response, a draft of a response for a program that can divide two numbers or it cannot do that. So I wrote some code. I would like to do all the possible divisions by 100, all the possible divisions of 100 by numbers between negative 100 and 100. So 100 divided by negative 100 is negative 1. And 100 divided by negative 99 is this thing, so on and so forth, until you get to 100 divided by 0, and then you're done. And then I didn't get to see any of the positive numbers because my program ended. So I only got to see half of my program's output. So how can I fix my program so I get to see the rest of the output? Anybody have a suggestion for me? Nobody wants to give me a hint? You all just, aha. So Alex and Isabel have put some code. So they both wrote, if denominator equals 0, what do we do if denominator equals 0? Well, we definitely don't want to divide, right? So where does the divide go? Somewhere else? We'll put the divide in a separate block. So we need the else statement and the divide goes there. So let's execute this instead. So now we have negative 1, continue for a bit. We get to negative 100, and then we have skip that. And then it's 100, and we're going on positive numbers. Yay! So now I get to see the entire program output. Because instead of crashing, I just did something else. This is something else. Does it really matter what it is? I guess it's up to you to decide what you want to do. But the point is that this outcome is very different because I get to see the rest of my code output. And John suggested if denominator not equal to 0. In that case, we're swapping when true and false occur, so we would swap the blocks. So here's a different, slightly different solution where we negated the condition with the exclamation symbol, which turns the equality into the not equality operator. Then we swap the blocks and we get the same output. So it's just the same code written in a different way. Thank you, John, for reminding us about the not equals operator. So how about some conditionals with other operators? Let's use the in operator. So here's an example using the in operator and also the not operator. So actually, this isn't the in operator. It's technically the not in operator, which is short for if not user choice in ice cream flavors, but that's a bit tedious. So we'll just put the not over here next to the in, and Python understands what you meant. What flavor of ice cream would you like? Banana. Sorry, we don't have banana flavored ice cream. Okay, maybe you have cheese flavored ice cream. No, we don't have cheese flavored ice cream. What if, do you have rock flavored ice cream? You got it. One rock ice cream coming up. So what happened here? Would anyone like to explain to me why I'm allowed to eat the rock flavored ice cream?
Because the words characters ROCK are part of that rocky road.
Yes. So rock is a substring of the one big string. And so the in operator has a different behavior when you're comparing a string. If this is a string, then you're looking for a partial match. Rock is a partial match. So I'm allowed to eat my rock flavored ice cream. Anybody have a suggestion how you would change this so that you're not doing partial matches? Do you remember the other way to do in that doesn't do partial matches? If it's not a string, what could it be? You remember any other types? Brackets instead of quotes. So the brackets are for starting a structure. Do you remember the name of the structure we learned? Tuple, yes. So for tuple, the main thing is the commas need to not be inside the strings. So let's add some more quotes here to get the commas out of the strings. That's the main thing. So if the commas aren't part of the string, then they are the comma operator that creates tuples. So now ice cream flavors is a tuple. So in will not do partial matching anymore. What flavor ice cream would you like? Rock. Sorry, we don't have rock flavored ice cream. Okay, but I really do like vanilla. You got it. One vanilla ice cream coming up. So now the code does the other behavior where it's doing complete matches only. Any questions about using the in operator with the if control statement? This is just combining things we already understood. So how about your exercise? I think you have time to do this exercise before the end of our class session, and we won't do nested conditionals because that's tedious. And then loops with conditionals is also tedious. So we'll just call it done after one more exercise with conditionals. So the example of string operators was the not in example. So, but it just have is, if, else. What if there's more than one kind of response? So let's say you want to sort something into 4 different categories: winter, spring, summer, or fall. So there's 12 months. Let's pretend that the months align with the seasons. In my opinion, December is in the winter. Like, you can make up your own idea of what you think is going to happen. But for sure, January is in the winter, right? So let's say the user puts in a name of a month and you compare it with a list of months that are in the winter. And then if it is in the winter, you print out, I love something about the winter. You don't have to love the winter, but it has to be a message that's specific to winter. And since the user didn't type in the word winter, the only way to transform the user input into that result is to use conditionals. So please do take a few minutes to try this. Please try to have fun. I know it's the end of the day, but I try to make these exercises not all based on just arithmetic, so you can have some fun. And then after that, we will wrap it up with some questions or the survey. So we have a survey, which I assume we'll send out by email, but if you're here, you can take the survey now. So we have this survey, which is a QR code in case you want to take a picture of your screen, or I could just drop the link in the Zoom chat if you want to do it on your computer. It's the how did you enjoy your training session today? So you can tell us what you thought about the training session. If you, or also just if you had any technical difficulties with the ACES cluster, that would be another way for you to let us know what you experienced. And of course, we use these feedbacks to improve our training over time. So we really appreciate when you give us the feedback. So I dropped the link to the survey in the meeting chat. I can bring back the QR code if you want to see it again. It's also in the slides that I posted on the web page. Is anybody still working on the exercise with the conditional statements? Do you want to tell me if you have like a draft of a solution. Okay, so Joshua has a draft of a solution. Let's take a look at Joshua's solution. So we have 4 tuples, which are different months. And then we have 4 in operators comparing the current month to a tuple. And then we have the input function to get some input from the user. So what's your favorite month? Let's say June. Spring flowers are pretty. So according to Joshua, he is expecting me to see some spring flowers in June. That's fine. I'm not going to complain about that because Joshua clearly demonstrated that he understood the assignment. So what is your favorite month? November. Not sure what season you mean. Yeah, because if you ever get to the November, your seasons are the least of your problems at that point. Thank you for sharing your solution with us, Joshua. So that will be the last of our exercises for today. I'm going to, so if you still have your interactive session here, one fun fact is you can just wait for it to expire in 31 minutes. But if you don't want to wait for it to expire, there's a couple ways you can stop it. So there's a delete button right here that will remove any evidence of this job from your local jobs cache. Or you can have the notebook shut itself down. So if you go notebook shut down, then the job will detect the notebook is no longer running and it will switch to completed. So you can see I have the completed state on my job cards. If you click delete, it also removes the job card from the list. So I don't like to click delete if I have another option. So I'm going to go with the file shutdown option. And the tab remains open, but it's been disconnected. So there's nothing you can do here. If you type, it won't save. It'll be like, no, I can't save. And so the job card switched to completed. There's no process running. This is a dead tab. And I am finished with that. Now the notebook for Python training, remember when we launched it, there were no parameters for you to put in except for the optional email address. And that is because I had already put in the job reservation. So after the job reservation ends, this will go away. But you can still use the regular Jupyter Notebook form. So if you use the regular Jupyter Notebook form, you have to type in your own options. So if you pick Python 3.10, which is what I said we would be using, you can launch it and you can get back to your files. So I have to wait for my new Jupyter Notebook to launch. Queued. Still queued. Starting. Why does it still say starting? It should be started by now. Yeah, it is. Okay, it started. So connect to Jupyter. And your files you can get to, they're in a directory named training and then today's date. So you just navigate to the directory and there are your same files. So for the rest of today, or whenever you have an ACES allocation, you can get back to your files. The difference between Jupyter Notebook for Python training and Jupyter Notebook is mainly the reservation for the nodes, so we don't have to wait around for nodes to be available. Hopefully that made sense to everyone who cared about it. So, if there are any questions, I would like to answer your questions. Otherwise, I hope you choose to fill out the survey and have an excellent, excellent 2 weeks. And I hope to see you again at the next session where I will teach some more concepts of Python.